I can just show you. Let's see.
Welcome to Propeller Live Forum, November 13, 2024. Okay, today, couple things. Nicolas will spend 10 to 15 minutes showing us his step direction driver for his CNC controller. And if you're interested, you could also look back at his previous presentation with X-Plane, where he created a live motion feedback cockpit. Fun to watch. And then the compiler improvements made. He's been working full time, and I think he's just uploaded them to OBEX. Good job there. Next month, in December, Terry Trapp will show us the Blitzen Holiday Property Light Controller, live from Tennessee. Here's a picture of that. Oops, maybe not. Here we are. So he has a circuit board with a P2 edge. Well, he's going to tell us about it, and probably a very high energy bill. I'm sure Johnny Mac knows what we're looking at here. So next month, that'll be fun. Also, there's something new on OBEX. You may have seen Chip's Tips. Raise your hand if you've seen Chip's Tips. Anybody?
It's only been there for like
Me too.
15 minutes.
Chips tips.
Oh, Chip's Tips, yes.
And yeah, the way you get to them is you go to obex.parallax.com. Which may not show up here because of my current bandwidth. So we won't worry about that. But anyway, obex.parallax.com has Chip's Tips. And there are 3 of them now. You like producing those, Chip?
You're asking me?
Yeah.
Have I done one yet? I don't think I've made one yet. Someone made one, but not me. No,
What's it called?
it's a good idea.
Somebody...
I just have been struggling to get this version of Peanut done, so I have not done anything else.
You must have ghostwriters.
Okay,
let's see. If anybody has anything to discuss today, please let me know. You can let me know by private message or just say something right now. If you have any questions, the meeting is informal, as you know, so you can raise your hand or just unmute your microphone and talk anytime that you wish. Separate item, I have 2 customers who are looking for code development for products that they've created. Both are hollow line spin. Back. I think I'm back now, Stephen.
Yes, we lost you for a bit.
Ah, that hurt. It went really fast when I disappeared. Okay, so I was saying that I have 2 customers who created products, and they both need some code proficient in Spin 1. One is a device using GPS and a cellular modem, and the second one I don't know too much about. So message me if this is of interest to you. I have a poor connection today, so I'm going to make sure Chip is host. And we will turn to Nicolas now. We have 2 Nicolas here, so it's Nick Benezan.
Okay, hello everybody. I just try to share my screen. Can you see my screen?
yes.
Okay, today we talk about step and direction signal generation. Why do we need this? I think it's the most simple interface to tell a motor to go to a certain position. It's one step signal, as the name suggests, and every pulse is simply telling the motor move one step in this direction or move one step in the other direction.
So it works, the pulse, like it has to go high then low to register with the motor? Or does the motor do like half steps?
Yes, today's modern drives almost all do micro steps. So in the past, we had motors that did just 200 steps per revolution. But today's drives have much finer steps, and there are also servo drives which support the step and direction signals. So today we can do this with a pretty high resolution.
Okay.
I want to start with pros and cons. As I already said, the situation today is much different than maybe 20 years ago. In the past, the stepper motors had a quite bad reputation, especially in the industry for driving machines, because there were a lot of problems. Of course, there's no feedback in traditional stepper motor drives, so you don't know if the step you command are actually executed by the motor. And if something went wrong or the system is not designed properly, everybody knows the symptom of lost steps. This means you tell the motor to move somewhere, but it stalls or moves to a false position. But I think the bad reputation is not justified today because we have much more modern drive technology, and if you do it correctly, then it's very reliable. I already said most servo drives today also support step and direction signals. So I think it's the most widespread interface for servos and stepper motors. Almost all drives support it. And yeah, there are other ways like analog servos or complicated digital protocols like EtherCAT, Profibus or something like that, but they have their advantages, but they are all more complicated than step and direction, and this is why it's still very common and widespread. Of course, as I said, you have to do it correctly. If anything goes wrong, you will, in most cases, don't have feedback, so the motor just doesn't move to the commanded position, and you need some sort of error handling for that. But yes, this is the topic of today. I try to tell you how to do it correctly, so to avoid most of the problems. Most controllers for stepper motors do it what I call the classic way. There was, for example, a very commonly used CNC controller software for the PC. It's called Mach 3. I think everybody knows it. And there are lots of devices like Arduino boards who support also step and direction signal, and they do it this way. You have a regular interrupt in your software that runs at a very high frequency, say something like 100 kilohertz, and then you run a Benezan algorithm that is normally used for line drawing on the pixel screen. And it's basically very simple. You go one step in the X direction, and each step you decide if you do a step in the Y direction or not. And with a stepper motor, this is the time axis, and this is the axis the motor moves. So for each interrupt, you simply decide to do a step or no step. So if you move the motor slowly, then your line is shallower, and if you move faster, this line is getting steeper. So you do more steps. One problem with this approach, the first problem is you can't make the pulse very short. Most drives need a minimum pulse duration of about several microseconds. So you not only need a first interrupt here, you also need a second interrupt to make the pulse end. The second problem is the direction signal provides the sign and tells you if you move clockwise or counterclockwise, and you can't change the sign at any time. You need a minimum setup time before the next pulse. So you need setup time before the pulse. So you actually need 3 interrupts, or at least 3 separate time steps to output these signals. And this becomes very problematic if you have interrupt latency. For example, your main program disables interrupt for several microseconds. So then the edges of these signals are shifted to some time that is delayed. So if the direction signal changes polarity too close to the next edge of the step pulse, then you have a problem because your drive doesn't know in which direction to go. And the last problem is jitter. This means you don't have a single and pure frequency of the steps. The reason for this is the aliasing. You have discrete steps, and if you only can make a decision to output a step at a certain time or no step, then you can't just output any arbitrary frequency. You can see it here. If the line or the speed of the motor has a certain angle, then you have different frequencies here. You have 2 pulses close together, and then here a longer duration with no pulses. So the goal is to do it better. This is the Propeller way, and of course with the Propeller 2 we have smart pins, so we can do this in a more elegant way. Unfortunately, there's no direct smart pin mode for step and direction output. There is a pin mode for input, which basically implements a counter that counts edges on the A input, and the B input provides a sign. But for outputting step and direction signals, we need to program either a numerically controlled oscillator or use the pulse and transition mode. And the direction signal, we have to use a sign and directly output this to a pin. So with smart pins, we don't need a interrupt frequency of hundreds of kilohertz. We can just update our pin once per millisecond. So we have a 1 kilohertz update rate. The advantage of this is we can usually program it in a way that we don't have this aliasing effect here. We can make the pulses 50% duty cycle and in most cases evenly spaced. We have a much lower CPU load because of the lower update rate, and in general we have less jitter. So we can look at a simple example code, how to do this in assembly language. I have simplified this a bit. We probably would need a bit more initialization code, but this is just the core. We have a main loop, which just waits for our 1 millisecond period. Then we read the number of pulses somewhere from a hop address. I assume that some other software provides us the next position where to go. So we get the delta position or the movement for the current cycle by subtracting the last position. Then we need to do a division, and because this only takes positive values, we need to take the absolute value, but we remember the sign for later. We start the division, which calculates the frequency we have to add each sysclock cycle for the NCO mode. So we have to do this division. The NCO mode outputs 1 pulse per 2 to the power of 32. Sorry?
It's a big fraction that's less than 1.
Yes, of course. It's less than 1 because the NCO accumulator is updated every clock cycle. And of course, we need to output less than 1 period per clock cycle. So it's less than 1. Because of this, we use the fraction division. Then we update the last position and update the timer. Get the result from the division, and the WY pin writes this to the frequency register, and WX pin writes the current phase and the pre-divider for the clock. So this is important because the division has some rounding error, of course, if it has a remainder. So it might be the case that at the end of our current cycle, we don't end up with a full pulse, but some counts more or less in the phase register. So we need to reset this every cycle. The value is 4 in the leading digit because I'll show you this later, because we want to start in the middle of a load time of the pulse, and then the counter in the NCO counts up, and when it reaches 8 in the first digit, the pulse starts, and if it reaches 0 again, then we have a falling edge. And this repeats and outputs a certain number of pulses until the next loop is started. And last, we need to output the direction signal. This is simply the sign that from this subtraction operation. And of course, these registers are not updated exactly at the same time, but I assume that our step frequency is much lower than our time we need to execute this a few instructions, so it doesn't matter really. And if there are some small errors, we simply reset the phase. We have a quite high margin for error because we have a 32-bit register for the phase. And if we end up some counts more or less, it doesn't matter because we reset the phase in the next cycle.
Do you
Sorry, I can't hear you. Do you have a question?
I think it was just some background noise.
Okay.
Is a 1 millisecond, what you have here is like a 1 millisecond time base, right?
Yes.
Is that sufficient for a lot of things, or do you need to go a lot higher?
That's sufficient for most machines I know.
Because
I
there's
can't imagine.
a lot of inertia and things.
Yes.
Yeah,
This
like the hardware
means you
won't have
a-
time to respond to the
Yeah.
pulse.
In most machines, well, of course, there may be some devices. For example, if you have a how is it called? When you deflect the mirror of for laser,
Like a Galvo scanner, like a Galvo, yeah.
Galvo scanner, then maybe a millisecond is not enough. But for most machines, CNC machines, drilling machines, pick and place machines, 1 millisecond is definitely enough. You have 1,000 updates per second, and the motor usually needs half a second to spin up to full speed. So that's more than enough.
So
Of course, you can choose. Yes.
Oh, go ahead.
So I think this is the simplest way to output step and direction signals. And we already have some advantages to the much simpler software approach. So we don't have the aliasing we had earlier, at least not inside one cycle.
Right.
Here we have the pulses evenly distributed throughout the whole cycle. So any number, it doesn't matter if we output 5 or 10 pulses per loop. They are nicely and evenly distributed. We have a 50% duty cycle, so we don't have the problem that our pulses are too short for example, any optocouplers or long lines that we need to drive.
Yeah, and you've always got the direction change occurring in the ideal spot too, midway.
Yes, exactly.
But now, would it make, I think you posted something a while ago where you're talking about getting really good machining. Let's say you're coordinating 2 steppers and you're using them to move an XY and you want to draw an arc, right? So
Yeah.
if you're drawing an arc, might it be to get the smoothest arc possible, would I mean, even though a millisecond time base is sufficient for moving the motors, if you were to get sub-millisecond, not that your frequency on the controls goes any higher than it is, but the resolution, like what can I say, like the timing precision, so you can have those pulses appear at very fine offsets. If they, then you could like make
Yes.
better finishes in machining, right? When you have more than one motor. So you kind of respect the two motors' inertial matters so that you can, it just seems like, I don't know, it just seems
So you're
like
like trying to
something could be done.
synchronize them better?
Yeah, so that you're synchronizing them on sub-steps, like, you know, maybe 1,000, instead of even down to 1,000th of a step, you have some phase relationship, which you control real carefully.
Yes. That's exactly the problem I want to talk next. You nailed it. That's exactly
Okay, all right.
what we need to care about.
Yeah, you need to like really oversample this.
Yes, exactly. So with the program I showed you, as I said, when we have a higher frequency than our cycle time, then we have the pulses nicely evenly distributed. If we have very low frequencies, so we have just one pulse every several cycles, then it's also no problem, because the motion calculation does the job for us, and it only outputs a new position if the threshold is reached. We can't do less than one step per cycle. So the rounding to whole steps basically makes this gaps, and we get one pulse every n cycles. But what happens if our frequency comes close to our loop update rate? Then it can happen
then your
that
resolution falls apart.
Yes, and here in this example, we have one pulse in the first cycle and then two pulses in the second cycle. So we have, on average, we have 1.5 pulses per cycle, and this causes, again, aliasing.
Yes.
And it doesn't help if we make our time resolution finer. It doesn't help, it just shifts to a different frequency where the problems come again. So what we eventually want is not to make the time resolution finer, but the phase resolution.
Yes.
So this way we could output 1.5 pulses per cycle, and we have a nice pure frequency over multiple cycles. So what we need is a finer control of the phase of the signal. This can be done by increasing the resolution of the phase of the NCO counter.
You know what, I think, I'm thinking about this, and the trouble is you have state that's hidden inside those smart pins that you can't know exactly, so you might as well just track it yourself in software and then do it just by controlling IO pins without relying on any extra smart pins.
Yeah, and some 10 years ago, I've seen somebody who did it with actual feedback from the step and direction pin. So they had rounding errors in their oscillator design, and so they counted back the pulses at the output and corrected these errors with software. But with a P2, this is not necessary. You can simply pre-calculate the error. So what's the trick? The trick is to not to reset the phase register every cycle, but allow for steps that are smaller than a full period of the NCO. This reduces jitter and also audible noise from the motor and provides more torque, because if you have aliasing in the signal, this actually means that the motor has to accelerate and decelerate each time.
Yep.
And this uses up some of the torque of the motor, so you don't have the full torque of the motor available to the mechanical load. But if we allow for the NCO to run at finer steps, and then we have some problems again. We need to account for the rounding errors, especially for the divisions that we need to execute. And of course, the setup time problem for the direction signal comes back again.
Yeah, because the problem is you sometimes wind up with net counts that you didn't, or net pulse counts that were hard to anticipate by changing the frequency around, right?
Yeah. So what we need to do, we can't just throw away the remainder of the division. We have to remember that and apply a correction in the next cycle. And if the direction has to change, that's the wrong picture. You see, with this solution, we have guaranteed that the direction change always happens only at the beginning of our cycle. But if we have, let's call it micro steps or final resolution, then our next cycle begins in the middle or at any point at the pulse output. So we have the setup time problem again, and we can solve this by looking a bit ahead. We have well, we can't actually look into the future, but we can record a buffer and look into the past. So we calculate our NCO values one step ahead. And if there's a direction change, then we round up to the next full step. Or we can also round down. It's not a problem. And but we have to also remember what we added and subtract it in the next cycle. Okay, then one last thing. What we also can do is add some filtering to the step and direction output generator. This could also be done in the motion control algorithm, but I added it to the step and direction driver because there is lots of cycles left in the calculation in the cog that does all the step and direction signal generation. So we could apply a moving average filter to the frequency, and this helps to avoid bumps or jolts which are discontinuities in the acceleration. And if we apply the filter, we round the corners of the velocity signal. And if we do this to multiple axes, this means that we cut the corners, which is normally not desirable if we really want to move around the corner, then we have to stop here and accelerate again in the different direction. But there are some cases where you want to cut the corner. For example, if the motion algorithm can't do real circles, you want to approximate that by a polygon. And if you then smoothen the corners, you get back the circle or arc that you want.
This reduces what's called jerk, right?
Yes. Okay. So let's take a look at the actual code.
That's cool. Is there an extension now for VS Code for spin?
Yes. I
Cool.
don't know if everybody can see it or if the font size is too small. Does anybody know how to increase the?
Yeah, it's in the menus.
It's in the menus. Okay.
Yeah, Steven made this.
Appearance. I think I just open it with Propeller tool. This is much easier.
I'll look up the menu setting for you.
And can somebody post a link to the spin extension in VS Code for whoever asked?
It's download from the marketplace. Yeah.
So
You just
this is
type in spin 2 when you're looking for extensions, and you'll find my extension.
okay. I don't want to explain everything in the source code because the assembler section is very, very complicated because of all those corrections, filtering, and what I have to do to avoid any rounding errors summing up. But here you can see the main interface. I've set the maximum number of axes at the moment to 6, but the P2 has definitely enough power to do a lot more axes than 6. So if you need more, just increase this number. We have a start function here. You can provide any pin number for the first step pin and for the first direction pin. And what's called ink pin here is the step what has to be added to go to the next pin of the next axis. So if you want to have the step and direction pins in the leaf, you can simply assign, for example, pin number 8 for the step pin and pin number 9 for the direction pin. And you set the pin increase to 2. So for the next axis, you have pin 10 for step and pin 11 for direction. Or you could put it without interleaving, just one following the other. So you have all step signals adjacent to each other and all direction pins following. Then we need time to synchronize. This is not important at the moment, but you definitely want to run the motion calculation maybe in another cog. So you need to synchronize the whole thing. If you don't need it, you can just pass the current value of the system counter. And period is the cycle time in system clocks. Then if we need to, we can set the filter length. There's well, the most important thing is, of course, to pass the values of the actual axis positions. I've chosen here that a simple shared array in Habram is a simple thing, because if your motion calculations run in another cog, you don't want to call a function here. So this simply returns a pointer to the nominal position array. Same for actual positions. This is, of course, not a real feedback from the motor. So if the motor actually would stall because it is overloaded, then you don't notice. But this is the output position from the filters, and there's a small delay, so you can also pull if some motor is still moving, or if there's some movement left in the buffers of the filters.
Nicholas, are you still
So-
using the smart? Yeah, you're still using the smart pins in this. You're using the NCO mode.
Exactly, yes.
Do you think, though, I'm kind of worried that maybe what's happening is you're having to do more work because the NCO is stateful and it's tracking phase, it's accumulating values, and the top bit is the phase. But maybe those things could be getting in your way. It might be easier because you still have plenty of time to do all that in software. Maybe you should just have your master loop perform those calculations in software so that you can then have tighter control of it, and you never have to kind of like do any guessing about what the state machine and the smart pin is up to, because you always know then. You know what I'm saying?
What kind of interferences do you think you'd have because of the state machine?
Well, I'm thinking that if it's free running and he's having to do something like some calculations to figure out what the errors might be at some point, because it has been free running, and it's sort of like you have to do some calculus on the side to figure out where it's going to be. But if you were controlling it at every point in the loop, then it might simplify the math, because you wouldn't have to be doing any computation to figure out what the smart pin NCO already did or has done at some point in the future as time went by.
Yes, I try to avoid that by not using any feedback from the NCO counter. So in the main loop, I do a wait count for the next cycle, and then I update all registers. So this is very precise to a single clock cycle.
Yeah,
Okay, so and is it still a 1 millisecond time base?
You can use a 1 millisecond time base, but you can also use any other cycle time, as long as, well, it probably wouldn't work with some megahertz,
Right.
but
But you could probably get
it needs
50 kilohertz,
about
100
100, needs, depending on the number of axes, maybe 100 or 200 cycles to update everything.
Yeah. All these kinds of problems are the same thing that happens in, like, audio signal synthesis or even graphics. All this matter of following curves and synthesizing information that creates like natural movements or sounds or visuals.
Yes, but well, it was quite some work to debug this.
Yeah, I'm sure.
But once it runs, it's very reliable. And
How do you
yeah,
set the acceleration and deceleration? Is that through the window time variable, I guess you have?
this is
The
only the
filter.
driver for the step-in signal generation. There's
okay.
no calculation about acceleration of the motor or any speed envelope or trajectory or something like that, this is completely outside of this driver.
So this
the
will generate,
motion. Oh, go ahead, Nicholas.
yeah, so this will generate the pulses for what time frame? Like what's your buffer of like steps that this does? Because I guess you said you're not doing a trajectory, but I'm curious of like how it's like how much time are we, I guess how many, I don't know how to explain it, but like what's the window of pulses that this is driving?
In the main loop, you just have, how far down do you have to go before you come back to the main loop? Because that might answer Nicholas's question.
You mean the minimum time I
Well,
need
just how
for the
much
execution?
functionality. You loop on the main loop, you do a bunch of stuff and you jump back and you go to the top of the main loop and over and over and over, right? So how much
Yes.
code is in there? At the bottom of that, there's going to be a jump main loop somewhere. There it is.
This is probably 100 instructions, and of course it has to be run for every axis. So I think it's for 6 axes, it's much less than 100 microseconds.
Oh, wow.
Okay. So it's over 10 kilohertz. Yeah, so that's probably above any kind of physical effect that you'd ever notice, right?
Yeah. And it's probably a bit waste of resources to dedicate one cog to this task. You could also do a lot of other calculations. You could probably compute the complete trajectory of a machine also in the same cog, but yes, I wanted to make a simple driver that everybody can use. So yeah, in my current project, I don't run out of cogs, so there's no need for any optimization in this direction.
So each axis has its own cog, right?
No, this is one cog, and it can
There was a
output.
software loop in the main loop that would do all the axes and then it would go back to the main loop again.
Okay. Got it.
And the update loop for the registers is actually very tight. It's only 8 instructions. So the synchronization between the axes is quite good, and all the calculations are further down.
So I guess if you weren't to use the smart pins, you would probably have to do axis per cog, do you think, or? So I guess it's offloading a lot of that processing.
Yeah, like the NCO smart pin modes are giving you super fine resolution that you don't have to babysit. Right. You don't have to you let them move the pin. But then what this loop does is it modifies the frequency that those NCOs are running at. Is that right, Nicholas?
Yeah, that's nice.
Yes, exactly. I just go back to the page of the presentation. This is yeah, in this picture, you just need to update the smart pin once per millisecond or once per 500 microseconds or something. And during the whole time, the smart pin runs on its own and doesn't need any attention from the CPU. So you can output not just 5, but you can output several thousand of pulses in this time without increase in load of the cog or
Yeah, so
processor.
you always have like a good 50% duty cycle no matter what the pulse frequency is. You never run into that problem like with the red line down there.
Yes, yeah.
So
Um,
the motion planning would be done above that, right?
yes, yes. This is a complete separate task, and
Yeah, this is just giving pulses and a direction change that's aligned with the middle of the trough.
So I guess what would the
um,
workflow look like if I had a Raspberry Pi running some Linux-based open source trajectory planner? How would I interface with this? I guess I would just tell it, here are the positions and here's the frequency, and it'll do it.
um,
I'm thinking
yeah,
of like a
you need,
6-axis robot arm or something, like how that workflow
Yeah,
would look
because
like.
you're probably, yeah, all those G codes are probably going to be handled just because of the way things work today and how workflow goes. They're probably going to come from something like a Raspberry Pi. Not that they'd have to, but that's going to be where the workplace is, where that data is getting generated. And then it has to ultimately go out to some, accurately timed signals to do anything, which is where the P2 would come in.
I think that Nicolas mentioned earlier that Mach 3 does that side of things.
Okay,
yes,
Mach 3 is like
I
a CAD.
have a program that gives you an interface like a CNC machine, and for example, I can just press start, and I don't know if you see the motor starts moving.
Okay, yeah.
And
It's cool.
these are the signals on the scope.
Slows down, reverses
So
direction, speeds back up, and then slows down.
exactly, and if I slide the feed override knob here, the motor now spins up. And slows down.
So is that similar to like, was it pulse density modulation, or like just controlling how dense the pulses are within a certain period, basically, to change the frequency?
Yeah, the denser they are, the faster the
Uh,
motor would turn.
yes, that's actually some sort of frequency modulation, not pulse dense modulation. That's a different thing.
Okay.
But what I wanted to say is, here you can see a very simple program that just moves forth and back. But of course, you can. This is a full-blown CNC controller, so you can also load.
Did
Okay.
you make that program too, that beam icon too, or is that something else?
Yes, that's an example for an application that runs on the main program on the PC. So it just sends coordinates to the propeller, and another application is the flight simulator I showed. I think it was 2 or 3 months ago. And here you have a pre-calculated trajectory that is sent to a buffer in the CNC controller on the propeller. And with the flight simulator, it's real time. But if you want to, you could also run the full G-code interpreter in the propeller If you had some sort of mass storage device like an SD card, you could put all the files in the Propeller board. Depends on your application.
Pretty cool.
Okay. So I think I'm done.
Thanks for presenting all this. Do you think, I'm still kind of thinking about these smart pins, is there any complex work you're having to do to try to determine what the internal state of the smart pin is? Or do you, I mean, how do you know where the 90-degree point is? Because you don't have access to that, do you?
Yes, of course, the step and direction signals are only an incremental sort of interface. You don't have any idea of the absolute position of the motor. So
Right.
you need to do some homing or referencing at the beginning. You move against the stop or to a point where some reference switch is located. So if the switch or an optical barrier is closed, then you know the absolute position of the motor, and from then you can just count the steps and you know where you are.
Yeah, okay. But when you want to reverse direction, say you decelerate, hit a stop, and then you can switch the direction and speed up again, start creating more pulses. How do you know? I mean, does it matter if let's say that it stalled with the pulse high, but it's not changing? Would it be safe to then switch the direction at that point? Or should the pulse be low before you switch the direction? Do you understand my question?
Yes.
Because if there's
Well,
no movement, maybe it doesn't matter, right?
Electrically, it doesn't matter, because only the rising edge of the pulse initiates the next movement. But mechanically, it's a complete different thing. If the motor stalls, it always moves to the next full step where the cogging of the rotor aligns to the magnets in the motor. So if you have a very precise sensor that can detect the angle of the motor or where you actually are in the coordinate system of your machine, then you can have a resolution much higher than a full step. But if you run against a hard stop, you don't know because the motor snaps back to the last full step.
Yeah, okay. I remember when we were getting our little motor control board going, I kind of had this epiphany that when you're dealing with multiple axes that are running concurrently, you can't have, and there's not a lot of point to having feedback because everything has to be coordinated. And if one of the motors starts to stall or sag, and you've got all these other motors with their own trajectories, it just has to work right. You can't really save the situation if you realize things are not where they're supposed to be, because it's like a dance involving multiple people. If one person falls and they're trying to coordinate, then the whole thing doesn't work. So it just has to work. So it has to be designed to just work, so that as you're executing your pattern of movements, by design, you can't accommodate a fault, because otherwise it's, I don't know how you'd say.
Yeah, I think that's when you need to like incorporate current sensors to know like if you'll be able to predict like, oh, we're about to stall or something's about to happen.
Right. But let's
FOC
say
control or something.
you've got multiple axes running and one of them stalls. Well, if you're going to accommodate that stall without losing your trajectory, you have to then suddenly slow the other motors down too.
Yeah, yeah. There are some stepper motors drive that have feedback. They have an encoder on the motor shaft, and
Oh, so you
this
just
is
go by
good
that.
this is good for knowing when you stall, but you can't do anything against it.
Yeah.
If
Yeah,
it
that's
happens, it's already too late.
Yeah, that's what we found. It's like if you stall, it's already ruined. You can't really
Yeah.
save the situation. So you kind of have to design everything so it's just for sure going to work when it does the job.
Yes, yes.
Because if
And
one guy stalls and the other guys are going full speed, now they're all out of synchronicity.
But
yeah,
so you end up with
there are applications where you can benefit from this. In a pick and place application, for example, you don't need a defined trajectory. It doesn't matter. You just have to know when you reach your destination.
Yes, yes.
And if the y-axis moves first or the x-axis, it's
I feel like
no
for
big
Unless
most
deal.
you're
But
trying
applications,
to,
you won't stall really.
yeah, but if you're trying
yes,
to
but there
avoid,
are if you have a robot, for
Yeah,
example,
robot,
and
yeah.
there's something in the way and
yeah, in
the
the
motor
way, yeah.
stall, you can retry later. But for a CNC machine where you have to follow an exact trajectory, you can only stop and switch on the alarm light and
Yeah.
say
Yeah.
something went wrong. Please check it.
yeah, your detection is only controlling materials waste at that point.
Yeah. I mean, in theory, you could monitor when something starts to get slightly out of phase. You could then start detuning the other motors, like slow them down a little bit so that you're not on schedule anymore, but at least your trajectory hasn't been compromised. Time has been compromised, but not the trajectory. Because in some cases, you can't compromise the trajectory.
Yes, but all these techniques are so complicated, it just doesn't pay off. You invest that money for the next bigger motor and you're fine.
Yeah, that's how it's solved. So at the end of the day,
Hmm.
you're doing programming which will be deterministic when it runs. Because there's no allowance for error. There's no if it's going to error, it's just simply not going to work. Yeah, so bigger motor gets you around the problem.
Yeah, and they're pretty cheap nowadays too. So
Yeah, Doug here, that little robot he built, he can get these. He gets them from China.
yeah,
But
somewhere online or something. It's like 40 bucks. Yeah, you can get a really high torque one. Yeah.
What's so cool is they built all the high current switches right at the load point. It's all built into the end of the motor. So you just give it power and then you give it digital signals. And you don't, rather than have a power supply with an H bridge and all these heavy wires running out, you just send the power wires out to where the motor is. It does all that little switching internally and does all the digital interpretation as well. So it actually is a great solution.
Is that a brushless motor driver? Or is that also a stepper motor driver?
I don't know, but you may not even have to know because it could be handled in however they designed it. If it doesn't report a fault, it did whatever you told it. So I don't know if those things are actually brushless or what. But by
If you're
closing
talking
the loop,
about JMC motors, they have both versions. They have stepper motors with integrated driver and they have servo motors brushless.
yeah, this thing he said he gives pulses to, and then it interprets it. But the scary thing is a lot of the firmware that exists in the world isn't that great, and it's because a lot of the people doing the work probably don't understand the finer points of what they're trying to accomplish. So they do things and it's kind of rough. Like I have this drill. I don't see it in here, but it's one of these 20-volt battery drills, right? It's a hammer drill. It's a drill and it can drive screws and it has like like some kind of what do you call a thing that limits the tension, limits the torque. But anyway, I can hear it run as I squeeze the trigger. Rather than it being very continuous, you can hear it go, "Zzz, zzz, zzz." You know, like they
Yeah.
didn't know that they could have made it more variable, but they go, okay, this works when it's in that switch, we're going to do it that way. But they didn't understand finer, like they didn't break it down and really get the science going for them. They just kind of said, okay, we're going to have a couple modes of motion, and that's it. And so that's how they made that thing.
And I feel like those companies they're probably pumping those out so much that they're trying to cut costs wherever they can, and it's probably
Yeah,
mostly mechanical engineers and maybe a couple
exactly.
electrical engineers working on it.
Yeah.
Hi, did I
yeah.
miss anything?
No, well, Nicolas showed us his 6-axis like motion controller. It's like a what do you call it? Like a pulse and direction
Yeah, I
system.
saw the little bit of that on the preview. Anyways, I was busy cooking pizza soup, if anyone needs to know.
Oh, thanks. Yeah, that's good. That sounds pretty good
Nicholas,
anyway.
thanks for sharing that today.
You're welcome.
Yeah, thank you, Nicholas. Okay, well, I had a few more thoughts on
So
that.
Chip, let's see, two things, Chip. You had some compiler improvements
Yeah.
to share, and then also Kevin has KevinBot v3, which is his Raspberry Pi propeller-based propeller motor driver robot with PLDC. So do you want to
should
talk
we-
compiler first, or do you want Kevin to show his robot?
Let's let Kevin go. Are you
All
ready,
right, that
Kevin?
might be good because it's nearing dinner time for him.
Yep,
Yeah.
I'm here.
All right, Kevin, tell us what you got.
Let me try and get my screen share to work.
Well, he gets ready. I think many of us have followed this project over the last 4 years. Where this thing started somewhere around 2020, and it's been a learning test platform, propeller evaluation system for sure.
Can everyone see the robot?
Yep.
So I've got all the code and stuff set up so I can just use an Xbox controller and then just drive it with that.
Neat.
Is that cool? Is that through the wireless Xbox protocol, or is that just wired USB?
Oh, I've got a Wi-Fi router on the back of the robot.
Oh,
right
nice.
there. So I made a special program on my computer. I can connect up to it and just send it commands.
It might help, Kevin. Could you give them like a high level block diagram of what you've got going on here? Because you've got computers, Raspberry Pis, propellers, and stuff.
Yeah, so it's really hard because I got my camera fixed in place here, but right around the back here, I've got a Raspberry Pi that's connected to the Wi-Fi router. Then right here, try and bring up a photo of it. Is this one? Yeah, I've got this custom P2 board. It's running everything.
Looks good.
And then I've also got Python libraries to be able to send it serial commands pretty easily.
What are you monitoring? Is that the current? Is that?
Yes.
Okay. So does that PCB you made have a current sensor on there that's monitoring that?
No, it's on the P2 universal motor drivers.
Oh, okay.
Let's see.
Is that like a brushless motor driver?
Yeah, these are the 6.5-inch hub motors that Parallax sells. Yeah.
Oh, that's cool. I didn't know they sold that.
And can we still get those things?
Yeah, they're very inconsistent in supply from China, but we can get them. I think we still have them in stock. They're the hoverboard style motors.
Right.
I guess similar to what O-Drive sells, kind of like those, yeah, like skateboard things or.
Yeah, you can get them on eBay, Amazon too. They're like $50 a motor. And Steven just pasted the driver into the chat for this too. It's a well-documented Parallax project that Steven and Chip and Michael worked on.
That's nice.
Yeah, I've got a I'm using the MQTT protocol for data transmission between the PC and the Pi. So you can just see. Might have messed everything up. Yeah, I've just got a really simple interface. You can just send commands.
That's nice.
Have quite a bit of fun driving it around outside.
How far can you drive it from your garage shop?
It can go pretty far. 'Cause the router in the back's pretty powerful. But I was originally using XBs, but I just kind of ran across some bandwidth limitations with all the data.
Yeah.
You just switched over to Wi-Fi.
You could probably go pretty far if you had a Halo, just like it's a 915 megahertz Wi-Fi, something like that. It's like pretty good bandwidth.
Yeah, and then for powering it, I've got a 18-volt drill battery. It can go for a little while.
That's a good solution. It's easier than a RC LiPo.
Yeah, safer too.
Yeah. It's got all the protection on there.
And everybody has them.
Yeah.
It's
So
cool.
Kevin, now you've got some good mobility with this robot. It's kind of where you wanted it to be, right?
Yeah, I was
This
gonna
was
add
your-
like a semi-humanoid type body on the top. Was also just gonna make everything out of aluminum instead. But this is just a test platform now. So
Anybody wants to send Kevin a bunch of money so he can buy all the metal he needs, go ahead.
Yeah, if you go to Send Cut Send, actually, I use them for a couple projects. You can get laser cut aluminum for pretty cheap. The whole patterns and everything you need. Just design it up in Fusion or something, and they can do bends too if you want to do that.
it'll work. But I've also got a FPV camera streaming to the driver client.
Oh, so you can
I'm
kind of do like
interested in
first person view.
Yeah. Well, right now that I'm trying to demo it, it's not working. But
I'm interested in the next level of this
There we
for
go.
distance
Oh,
so that
nice.
you could drive it downtown and still have a live video link.
Yeah, that's pretty good FPS. Pretty fast.
yeah, I've got a slight issue with it. It just stutters a lot. Sometimes you get around 100 FPS, sometimes it just goes below 1. So
Frame pacing is a dark art understood by very few. I think it is almost impossible if you have your client on a PC to actually consistently sync it up with the monitor. It may in fact be impossible.
yeah.
Nicholas, your Halo Wi-Fi is just a Wi-Fi extender.
Halo Wi-Fi extender.
That's just an extender, right? 900 megahertz.
No, it uses a different yeah, like you can connect Wi-Fi devices, but you would have like your Halo gateway. I guess he would have it at his house, and then he would have a Halo receiver on his robot.
Right.
But it still uses the same protocol, so
Yeah, so you're giving yourself RF freedom.
right. Yeah, you should be able to go a lot further.
So
Then you also have to think about the antennas too.
Sure.
you don't know what frame per second your camera actually is capturing?
It's 30. But I can tell this FPS counter is not accurate. I'm not getting anywhere near 30. Yeah, about maybe 10, 15-ish most of the time.
Yeah, I wonder if you would you get a more stable, like if you averaged it out over a course of a few frames or a few seconds or something.
Yeah.
I was just thinking you could add a Starlink Mini to this thing and send it autonomously anywhere in the world.
Yeah, that'd be cool.
Without the line of sight drone requirement.
Did you make this software too, this UI?
Yes, I've made the whole thing.
Oh, that's
And
great.
this plotter tool is pretty powerful. I can say, let's get some more data, and say, view an average of multiple plots. Yeah, something else turned on.
Is that all written in Python too?
Yeah,
That's cool. What package did you use for that?
I'm using Qt for the whole UI,
Oh, Qt, yeah.
and
Nice.
then PyQt graph for the graphing.
That's cool.
Got all the
I didn't realize I had good libraries for that, for graphing.
configuration. You also got log viewer and controller mapping. If you have multiple controllers plugged in, you can drag and drop these around. And the first one's the one that's being used.
What kind of sensors does a robot have?
Yeah, I've got most of the sensors are put in this graph. So I've got a IMU, gyro / accelerometer. And this way. You see the green
yeah,
line.
nice.
And I've also got thermometers that will be attached onto the motor mounts. Measure the temperature of those, as well as just environmental temperature and humidity. And then I've got voltmeters for the batteries. We've got 2 of them on those boards.
Kevin, are you getting pretty smooth ramping and smooth control from the motor driver software now?
Yeah, definitely on 18 volts. I had quite a bit of trouble with a 12 volt lead acid, but now that I'm using 18, it's much better.
That's good. I think we've all kind of concluded we need 18 to 24 volts to
Yeah.
really run those well. Chip, maybe you could do some muting for us.
All right, let me see.
Usually the offending person is at the top of the list.
Okay. I don't see anything.
So I'm curious just for my own interest. I'm taking a robot like this and running it downtown. The issues are control and then video, right? But with a Starlink Mini, you could solve both of those. If the Starlink Mini allows itself to be moved around, right, and still knows where it is, because I think there's some restrictions on that.
Yeah. What I have here should be okay for just driving it around as long as you're about 50, maybe around 80 feet away from it. You'll be pretty good with video. Because it has its own router.
So I have that robotic boat project, which I was using XP 900 megahertz, I guess the long range ones, and it could get out of sight, and I could still drive it around, but I didn't have video link. I didn't have a good video system because the video tools are kind of, I don't know how to describe them. Analog, they just felt junky all the time to me. Like I really couldn't get a reliable video signal.
It'd be interesting in that
I'm
case.
so wondering if there's,
Yeah, Ken, it would be interesting to move to what Nicolas was suggesting. That's a 1.5 kilometer range network bridge.
Yeah,
with
it's called
Wi-Fi.
Halo Wi-Fi. Put it
Yeah,
here
it's
in the
Halo
chat.
Well, and these FPV pilots are getting,
Asia
10
RF.
miles. 10 miles, but they're in the sky. I think on the ground it gets more difficult.
Yeah, you tend to have things reflecting and just impeding your signal.
Yeah, buildings like cars.
Yeah. And bouncing it elsewhere instead of back.
What's cool about Halo too is it also makes a mesh automatically. So
Oh, interesting. So you can put multi-point receivers.
yeah.
Interesting. So you create a reception-rich environment.
And by
I'll look at
Halo,
that.
you're talking about 802.11 AH, I assume.
Yeah, I guess was that the Wi-Fi 6?
I'm seeing 11 AH as a standard. I wonder, certified Halo. What other Halos do we have?
So Kevin, you've got this working kind of the way you wanted now. Are you going to move on now to the full-on aluminum humanoid plan with the
Hopefully.
googly eyes and all that?
I've I don't know if you've seen it. I don't have them working now because I'm still working on it, but I've got two little displays here that are gonna have some neat little eyes that just sort of bounce around.
Yeah, you showed those last time we met. They're really nice looking. Well, any questions here for Kevin?
Kevin, I like the 18-volt battery idea from the drill. I think you said a drill. How do you connect to that?
Well, let me get my camera working. Back here I've got a 3D printed little thing because these batteries have a stem that sticks out. And then I bought the little contacts for them and then just hooked some wires up. I'm using Ryobi batteries.
Okay, that's nice. And the motor can take that. The motors can take that voltage.
Yeah, they can go up to I think 36, but in software I think it only goes to 25.9.
Okay.
Is that the
because
only
they didn't have a
battery
drive.
driving it?
Correct.
The drivers could probably go higher. We just haven't, I didn't have a high enough voltage supply to figure out what values would be used. Then I can add them to the driver once we know that.
Well, I guess the driver is really controlling the current through each phase, right? More than, I guess the voltage isn't a primary concern. As long as the power electronics can handle it, I guess.
Agreed. There was just feedback values that are adjusted based on voltage, so we can,
Oh, okay.
based on what we know about voltage.
That connector, did you design that yourself? The 3D printed one, or is it on Thingiverse or something like
It
that?
was on Prusa's printables.
I see.
He was one of the first results for just Ryobi battery connector.
Which Prusa
Yeah.
are you using?
Could you repeat that?
Are you using a Prusa yourself?
Correct.
Which one?
I've got two of the older Mark III S's.
Okay.
They
I'm running the same
just
thing.
work great.
Yes.
I have the Bamboo Labs P1P. Really gives Prusa a run for its money.
Really? You like it? Nice.
Yeah, it's really good. I mean, for $400, you can't beat it.
Nice.
Pretty much plug and play. I like Prusa though too. I had a friend that had one. Worked great too.
Yeah, my interest is being piqued by their latest 4. The 4S.
Oh yeah, that's the pretty big one, right?
I'm not thinking XL, but the one before it.
Oh.
But XL is intense also. I just didn't want to pay the monies.
What I didn't like about Prusa was, I'm spending all this money on it, and it comes with 3D printed parts on it.
Yes.
Which I get the point of it, 3D printer, but I wish it was just like machined aluminum or something, or I don't know,
I hear you.
cast aluminum or something to give it better.
I can
rigidity.
I can tell you though, it's the 3D printed parts haven't been an issue for me at all, and so it's been really nice.
Yeah, I guess it's not like super critical parts, I guess.
Correct. Yeah, they were nice in keeping them out of the critical areas.
I've got a question here about the drive code as well. I'm not sure what units are being used for the current measurement, but the more power I send them, it goes negative.
That's curious. Did you configure you did configure the battery voltage correctly, right?
Yeah.
Well, I don't know if that's correct or you found a bug.
Because I've got around -8 million here. And just idling. Got around -15K.
That seems weird.
No, that's -150K.
You have any, and are there any transport issues with the values you're transporting? You missing MSBs or setting MSBs by accident or anything?
No, I was also messing around with the HDMI debug, and the values I'm pretty sure were the same.
Okay.
It was a little while ago, but yeah, they were also kind of weird.
Well, Kevin, contact me directly. Do you have my email?
No.
Okay, I'll DM it to you. Contact me directly with the values you're seeing and what you're driving, and I'll try and replicate it and correct it.
All right, I'll do that. I've also got all the source code for everything is all up on my GitHub page.
Nice.
If anyone wants to take a look at it.
Is there any touchscreen LCDs you guys have?
I don't know. I think someone on the OBEX has made a driver for one, but I don't know if Parallax carries it. You could probably get it on Amazon.
Okay. There's a lot of cheap ones on Amazon, but I was wondering if you guys had like a little. I have a customer I'm working with, it's like more of an industrial automation project, and I want to do a touch LCD with it. But
Well, I think if I can
Let's
remember the
see.
display of it, Tony Mack and John have been using the touch displays on their devices. Nextion, yeah, that's why I was trying to remember it. He just
Yeah.
texted it.
We recommend the Nextion. They're really easy to
next
program.
gen.
Yeah, Nextion.
Oh, Nextion.
Oh, okay.
They're really affordable, and so far I've not had any failures on any of them.
Oh, these look good.
Get them in all different sizes. I've used their 7-inch, their 5-inch, their 3.5-inch. I've not used the smaller ones. I think they have like a 1.5-inch diagonal and a 1.8, but they have a 4 different versions that, you know, all the way up to you can play video on them, that kind of stuff. But they've been wonderful.
And you've been using it with the P2?
Yeah.
Johnny,
too.
yeah.
Yeah.
It's a really
That's
easy
awesome.
interface to use, and you download the screen definitions directly to the device, and then you just get touch coordinates and things like that. Tell it when to change pages.
Oh, so you have a separate program to generate the graphics?
Correct. And John,
Yes.
somebody
Yes,
was
an app
yeah.
on the PC, I think.
John McPhalon
Yeah.
was saying he could actually show us the interface. He's got it open right now.
Oh, that'll be great. Yeah, because this would be awesome to use.
Yeah,
I
sorry.
actually
I
needed to
unmuted
control a stepper
myself.
motor.
I'm actually in Dallas working with Josh. I was just editing Nextion code. So is it Nicolas Montoya where you were the one that were asking?
Yes.
Okay. So the Nextion is a smart device. It's a touchscreen device. You have to code it too. So it's interesting. And the upside of that is that it's pretty easy. It has a C-like scripting language, but all of that overhead for screen management and those kind of things happens inside the Nextion. So the P2 is not bothered with that. And so there's a very simple serial interface. What I do, and I'll show it. Are you running the meeting now, Stephen? Can I share my screen?
I think you can. Chip is. Have you turned on others?
Okay.
I'll show you because I have the Nextion editor open right now. I was just working on it. Let me see if it'll let me share. Oh, it is. Okay, so can everybody see my screen? The black screen that says production right there?
Yep.
Okay.
Yep.
So just quickly, and there's an old video. We did this as a project. What somebody was saying is, doing the screen resources. So here, since I have a lot of apps open, can you guys see, did you guys see a change in my screen?
No.
No, it's still showing the Nextion editor.
Okay, hang on. I just shared the Nextion. I want to, sorry, that was my mistake. Where is the share stuff? Come on. Well, forgive me. I screwed that up. I'll just go back to the Nextion. What I do, so you can see over here, do you see this? It says Elite.
Yep.
Okay. So these are just PNG files. I'm using a 2.8 inch. It's fairly small display. This is an interface for a product that we're doing. And so I developed this strategy with John Huffman and Johnny Jib. We did a project for he has a really nice big Ultimate is the name of it camera controller for Jibs. So we did this strategy. One of my favorite utilities is a vector tool called Inkscape. It's like a freeware version of Adobe Illustrator. So I do all of my screens in there. At whatever the resolution is. The resolution of the screen I'm using is 320 by 240, and then I export them as PNGs. Now, you can see up here, these are the objects that the Nextion has. I only use a few. So, for example, you see it has a button, but it's not very nice. And so, for example, let me move that out of the way. If I go to my menu screen, this is my menu, and what happens is over in the screens, you'll see here's the top layer of it, here's the bottom layer of it. You see where everything lights green. And then what happens is I use this feature called a crop. So when the press event of the crop will show a portion of this screen. So the point of it is, instead of using a lot of their base widgets, which are kind of, I don't know, they're kind of crusty looking. I wanted nice rounded buttons, looking a little more modern, and I wanted them to light up the way I wanted them to light up. So I just used the crop feature for nearly everything. And so here are all of my screens. So you can see, for example, this particular screen, the game mode screen, has buttons. So you can see those light green, but I also have what looks like sliders. Because I'm using one of the it's not the high-end display John was talking about, so it doesn't have a lot of fancy features, so I just did it myself. And I'll run the simulator. One of the great things about the Nextion I really appreciate is they have a nice built-in simulator, so you can check all of your code without having to even hook up a display. And so again, you'll see a lot of these screens are doubled up, and then I have a lot of little graphic elements that I use in later. So you saw, battery levels, flags, and this is a laser tag thing. I worked for a laser tag company. So over here is where you define your various screens, and forgive me if I seem like I'm struggling. I've got the Zoom stuff on top of my screen. But one of the things that you can do with any object that is inside of the system is you can attach code to it. So for example, here is a button that I made out of a crop field, and you'll see that the crop field has a touch event and a release event. And so in this case, now I've got an extra object on here that will automatically show the region underneath the button when I click on it. So that'll make it turn green. When I release it, in this particular case, it jumps to the game screen. Now, so this is all very internal. So you could actually do, because a couple of the Nextion devices have local I/O on them. You could make a standalone device out of it for really, really simplistic things. And now what I do with the Propeller is the Propeller needs to know where I'm navigating in the system. So you can see when I go to the game screen, there's a pre-initialization thing. I won't bother with going through all this. But then when everything is done and it's ready to show the screen, this is the message that I send to the Propeller. So it's just page equals 2, and then there's a carriage return on it. Because this is a really small scripting language, you have to tell it how many characters you want to set. And it's important too, because if you do a new line like this, or sorry, a return, it will, if you say 0 for your character count, it will append a new line as well, which this is an extra character I don't need. So what I've done on the Propeller end, so this is the code that John uses and I'm using here, and again, I think it's an OBX, is I have a parser that understands this message structure. There is a command on the left side of equals and a value on the right side of equals. It's really stupidly simple, but very, very effective. So anytime there is a change, we can do that. Now, another thing that you can do in the Nextion, so here are its global variables. So for example, I have an integer, and they only have 32-bit integers. There's no other types in this system. So again, it's very, very simplistic. This, when I'm going through, because this is a game piece, when we're changing values, I don't want to be updating the flash all the time, every time somebody changes one thing. So what we made the decision to do is once you're done with your coding, we didn't have a place to put a save button. So we just go to the ready screen. And on the ready screen, if this value is not 0, then it sends that message to the Propeller. The Propeller can actually read all of these things. So it knows how to ask for these things. So for example, now these are, you see where it says set by host. These are values that will show on a screen. that the user sees, and then this the Propeller uses, so I know that my screens match up. So anyway, I've gone on too long. Let me just run this simulator really quickly.
That's all through UART, right?
Yes, it's a 2-wire serial. They have reasonably fast baud rates. I'm going at 115, 200. It's plenty fast. It can go faster. And oh, debug, here you go. So like I said, what's really nice is they have a debugger. So here it shows the screen. Now I have a thing. I have to go manually put in the code that the Propeller would send. If everything is fine, the Propeller will send it this message. It will say page menu.
So this has its own API that you have to follow.
Yeah, and well, yes. So this is a command that's there, and in my driver, my Nextion driver, it covers all of the commands, and I'm not the only one that's written a Nextion driver. If you prefer C, there is a C driver that is more in line with the Arduino driver. Here's the difference between them, though. The Nextion C drivers use kind of arcane codes for each of the elements. I did everything in plain readable text. So it may take a few extra bytes to send a command, but a human can look at it in a terminal and see what's going on. Or and so here's a demo of what I was talking about, where you notice when I click on the button, it turns green, and then it'll go to the new screen. That's using that crop feature of saying, when it's pressed, show the screen underneath or the area that's defined. And so in this particular case, I'm also, just doing little simple tricks. I use almost none of the crazy features of the Nextion, but make really nice displays. Like I said, John Huffman at Johnny Jib, he and I worked about a month on his project, getting the interface going, and it's fantastic. And his customers like it. Now John, every time he sends me a new thing to look at, he's got all kinds of crazy extra stuff on there. So it's very straightforward to work with. They're inexpensive. And again, and to John's point, because when I was helping him with his original project, he had looked at some other products and sent them to me, and we were trying to code them, and they were just a nightmare from a service standpoint. The Nextion display has a 4-pin JST connector on it. One of the displays we looked at had this nightmare connector that they only wanted to sell to us.
I've been using like this 4D Systems one. It's been okay. From Australia, but it's more expensive. And
now again, for really simple stuff, so in our case, it's fairly straightforward. I tried to make a simple system. We've shown a preview of this product. We're going to show a kind of working version this time, but it's been really the people have been really happy about it. So in this particular case, probably, I don't know if it shows, but there's a spinning bullet in the middle of my screen.
Yeah, I see it.
So cool. This is one of the cases where there's a timer object internally. So I'm using the timer to do that. And these outside graphics are changeable. So we have a couple of different modes with this device. It can either be shot at by our laser tag guns, or you can press buttons that are on the device. So if it had been put into button mode, I can do that. Oops, game type. So this is that slider thing. Again, it looks like a slider. It's just two graphics. I show one or the other, and so really, really simplistic. And so the code is very consistent all the way through. So if I go to the ready now, this shows the user, hey, you set this thing into button mode. So my boss and my colleagues and everybody's been really thrilled with it. And it's not hard to do. It's just one of those things where there's a lot to do. So John and I did this, and I do this all the time. Again, Inkscape is one of my favorite utilities. I create all of my screens in Inkscape first and kind of situate everything and organize them, make sure everything's consistent. And then I export the PNGs or the smaller graphics as I need, and then load them in. And then I'll stop this. Let's see, can
you get these on Mauser or something, or?
I get them. I don't, you probably could, but I tend to get them from Amazon. because they always
Oh,
have
they're on
them.
Amazon.
They're a
Okay.
product of Seed Studio, so you can buy them directly from Seed
Oh.
as well.
Okay.
What I was going to do is, where's the splitter this
I
way?
see there are discounts on some of the Nextion displays today on Amazon too.
Let me.
That's
So
pretty good.
here's an example of what the code looks like. It looks a bit like C without the semicolons at the end. And there's some kind of persnicketiness with it. It is simple because, again, they're running it on a really small little microcontroller on the device. But it's, you know, it seems clear you've done a lot of programming. You could pick this up in a half a day probably and go to town with it. So again, then all of the user interface stuff is in the display. And in my case, I just have, I can tell the Nextion to go to a screen if I need. And that's what we do on setup. On this particular product, it boots up with the logo screen. Screen 0 is what will load up. So my logo is what loads up. If there's a failure to connect to the P2, there is a timer on that logo page that will take it to an error page that says there's no connection with the host. If there is, though, if the P2 boots up, gets everything it needs, then it will direct the Nextion to go to the screen. And then the user has control from that point forward. And once they go to the ready screen, that's when the P2 on our side says, okay, ready for an RF message, or our system uses XPs to do start commands and game commands and all that, and that's when it does the gameplay stuff. Yep. But they're a lot of fun and nice and easy to use.
So you wrote that code, but I guess there's ways to set the events through like the UI. So how much of the code is generated versus how much do you have control over?
You mean this?
Right. Is that generated?
You have to write everything.
Okay. That's
yeah.
cool.
So they have all of these objects, and when you drop them onto a screen, they have events associated with them, but there's no code there. So for example, I probably won't hurt anything if I drag a button over here. So here's a button. You can see that here's the touch event and the release event. There's nothing in there. So you have to decide. Now you see this checkbox here that says component ID. That's their internal serial communications. It's byte oriented. And so there's like I said, there's an Arduino driver that uses that, and there is a C driver for the Propeller that also does that. But
so basically it would send it over over UART automatically.
It's still serial. Yeah. Yes. Yeah. It does. Yes. So in my case, I'm using the prints statement. So I'm sending it manually, but I'm sending it as plain text so that I can see what's going on in a terminal, or I can use a external terminal to test it. And I will often do that. Once I have the Nextion code loaded into the device, then I'll just use the P2 as a serial repeater, and I'll just send the serial codes and test them and make sure everything's going. I'm in Dallas at the moment. I normally live in Los Angeles, getting ready for this show. But when I lived here before, I met a guy who did control equipment for oil patches, and he did everything in plain text. And the reason was he didn't need specialty test equipment to look to see what's going on in any of the systems. He could just watch text flowing by and spot issues, and that just stuck with me. And so that's what I'm doing with the next.
That's a good idea.
Yeah, there's not a lot of data, it's just really simple commands, to and fro.
Well, that's cool. I'm gonna order one of these because this looks like it'll be better than what I'm using.
They're cheap and easy to come by, and again, with your program.
How's the SD card? Is it industrial rated kind of stuff for vibrations, you think, or is it kind of more stationary type product?
I don't know, because the stuff that I do isn't moving around, and neither is John's really. I mean, John might have his controller on the end of a large, on the moving end of a crane or jib, but that's not vibrating. It's just moving. So I don't know, to be candid.
No worries. Yeah.
No, I will say their help forum is not as good as the Propeller help forum, but you can occasionally get good information out of there.
John, I had in writing Windows apps, I always do the same thing, effectively do some kind of cropping thing, because when you bring in those controls, if you put too many on a page, it bogs the application down and
Yeah.
you lose snappiness and everything goes to pot and it never works exactly how you want. So it's great to just handle all that stuff on your own.
Yeah, so if you look, well here, so this is so here's the inspector here. So you see it's a crop thing, and I'm saying this is the hard point control. So the normal picture is 7, which if I come over to my pictures, oh yeah. So the reason I was saying why is there's different. I actually have a cover there that I hide the rest of this with. I won't bore you with the details of the game, but when this is set to no, these controls are not available. And some of these are actually just graphic elements, so I can't disable them. So the nice thing is, since things are really simple with Z order, I just put a black cover over them. And if you click on it, these things don't see that. And by making this black cover invisible, then you can press through it. So they have ways you can, like all of this text, everything on here, other than these things, that those are the actual my changeable elements, but everything else is graphical. And so you'll see anything that can be changed now, even though you see there's a border around that slider, that's the crop element. So you'll notice on the second page for that, it has the yes. So what happens is, I think it showed this, when you have the release event, it checks the current value of the variable that controls. And then down here, it will set which picture to use, whether it's from the top page or from the bottom page. And so that's how I move those sliders around. And the same thing applies to the buttons. It's just that they're dynamic because they respond to, well, this one is too. They're doing exactly the same thing. So again, I've simplified my life with any kind of button or visual thing. The radio buttons on this, there's a screen where you can select if you're doing a flag game. All of these, every one of these things, even though you can see here, there's a radio button feature. I'm doing everything with crops. So my code is really easy all the way across. And to Chip's point, it's much more snappy. And I just like the way it visually looks. So for example, in our laser tag games, the Alpha team is red, the Bravo team is blue, the Charlie team is green, and Delta team is purple. And so you can't do that with the standard things. And I just made them look a little nicer. And does everybody recognize I am using the parallax font on this?
Oh yeah.
Oh.
I'm using a military font for titles and the parallax font for
Yeah, the parallax font.
The parallax font is fixed pitch, so it makes things nice. And what you end up having to do is you have to import the font, and then it creates, I guess glyphs is probably the best way to put it, because that's a one part. It doesn't have nice aliasing on this particular display, but still it's a fairly small display. And if you saw it, you'd say, wow, that looks pretty nice. And Chip's known me for a long time. He knows how fussy I am with the aesthetics of everything in my projects. So we spent a lot of time on the screens. And like I said, when we showed a preview to some of our customers, they were really thrilled. And the nice thing is, because one of our guys said, it's a touch screen, people are going to be wary of it. I said, what are you kidding? Everybody carries a touch screen around and talks into it every day. And that was the reaction. The customer said, oh yeah, I can do this. So it's an inexpensive.
Touch plague is real.
Sorry?
Touch plague is real. I think I have we have a bunch of kitchen devices with a touch panel that does nothing except control like a thermostat and a timer, and none of them work properly.
But it's nice. So one thing I've got to figure out for John and for me is, you can download the code to it serially. So for example, my particular project takes about 4 megabytes of the 16 megs that are in the flash in the device that I'm using. And so we download it serially. There is an SD socket on the back, so you can pre-compile your code and drop it into the SD socket, and it will load it in that way. It's a little faster, but not terribly convenient for my customers. So a step that I have to take next is learning their serial protocol, because you can upload it serially. You can see there's a button here that says upload. If I had the device connected to a USB to serial interface, which I did earlier when I was programming it, I could upload the code over that serial link. So I need to do that so that, because I have an SD card on my P2 for playing audio. And so that would allow me, I could put the new HMI file onto there and then upload it. So that's a future thing that's coming. Anyway, it's worth buying one to play with. They're really nice little displays and fun to play with, and you can do, I think, nice things with them without a lot of expense, other than the time if you're being fussy like I am.
That's very cool.
Yeah.
Huh.
Well,
It's kind of amazing how many display manufacturers there are, but it's still very difficult to make a decision.
Well, yeah, all these things, they engage the customer, in some kind of complicated way. I mean, this is the problem with the Propeller. It's like, it's very complicated, and it's asking people to
Yeah.
make years commitment, to it. And so at least that thing does something that's fun and understandable, and it might take, a week for someone to get pretty good at it.
but I told somebody, maybe it was John, it's like it's a 9th cog for my Propeller project.
Yeah.
Yeah, that's a good point.
Yeah, I bought one of those to check it out. It is very easy to use, and if you just need simple, I think here we saw an example of taking it to its limits, but the graphics are the regular graphics are relatively simple, but it's also really easy to use. So,
well, as John Huffman was pointing out, they have a range of displays too. They have a really nice one. I brought one with me for this road trip to experiment with that will do translucency and PNG transparency, alpha channel stuff. And it will, for example, so the little one that I'm using here, which I think is like $25 for this project, you buy them one off. As I said, it has an SD card on it, but the SD socket can only be used for upgrading the firmware inside the device. You can't do files and stuff with it. On the higher end display, you can use, there's a file system that works with the SD socket, and you can play audio and video. So we have an idea for a product that, again, in laser tag, we have these people called referees that run around with a special program in their laser tag gun so they can command things. And we're going to put that into a box with a touch screen so that we can do other things. So for example, again, as I mentioned, we use XP, and we often want to know how we're doing, if the frequency we're using is busy or not. So if anybody that's used XP has probably used XCTU, and there is a frequency scanner in there that'll give you kind of a busy graph of what's going on. I put that into the P2, and I actually used the debug screens in the P2 to do the same thing, so that we could send it to our PC consultant, because he's adding it into our PC program. But I want to put it onto a Nextion screen so I can go out into the middle of we do a lot of outdoor events, and stand out there and press a button and see which XP channel is the least busy and set the system to run on that. So there's lots of neat things. John Huffman, did I miss anything? You've been really quiet.
Isn't the bar you go to called the 9th cog?
I'm not much of a drinker these days, but if there was a 9th cog bar, I would go into it.
The 9th cog.
Anyway, sorry, I didn't mean to take so much time. Chip, I really do want to hear about your pointer stuff.
John,
Okay.
by the way, that was very impressive. I was really impressed by that. Simple,
thank you.
easy to use and set up. It's great.
There is, as I was saying, remember when the back in the dark days when the government tried to lock us in our houses, that's when we started doing these Zoom calls. I did a presentation. So it's on the YouTube page for Parallax. There's a presentation on this, and there's some code up there. And I'm easy to find in the forums. So if my code's not up there, if you need them, I'm available. People know how to get a hold of me. So Nicholas, I'm extending that to you if you have a question or
Great, thank you.
I participate in the forums heavily. But thank you, Grover. That was kind of you to say. Give us the pointers on pointers, Chip.
Okay, here we go. First, I want to, let me see. Let me get my screen share going here. Okay. Let's see. Okay, where is my screen? Oh, it's over here. Okay, I see it. All right, so a few pictures first. This is the robot I was talking about. Okay, that Doug designed. So you see those two motors off on the sides? Those are steppers with brains built into them. And what I didn't finish saying, I had a thought when we were talking after Nicholas's presentation about these things, that hopefully, now these motors are pretty cool, right? Because you just plug power into them and then you give them step and direction signals and they take care of everything. But if they have crummy firmware in them, they're going to have issues which can't be gotten around because you can't get to the actual control. You're only dealing with their firmware in their controller. So hopefully they did that part pretty well. And Doug's experience so far with these Chinese things is that it's kind of hit and miss. They have some weird characteristics that are, as you'd expect, kind of hard to get around, but we'll see how this works. But anyway, when these two motors both turn clockwise, I believe the whole gantry moves to the right or to the lower right. When they both turn counterclockwise, it moves to the upper left. Now, this is the weird part. When they go opposite directions, they move the Y in and out. You see that thing on that long thing on a linear bearing? You guys understand what I'm saying?
Yep. Wait, so when the left and right go opposite directions?
Yeah, when one turns counterclockwise and the other turns clockwise, it has the effect, the way the belts are wound up, that it moves the Y, either to the lower left or the upper right. And then when they move in the same direction, they move the X. So there's some funny translation for motion here. So you can make that thing move any direction you want. But
interesting.
So
yeah,
it must be a single belt that's hitting all 4 points.
Yes.
Because if you oppose them, it would pull the
Right.
Y. And if
it is.
Yeah.
Like a McPhalon wheel, thinking of like a
Yes.
McPhalon wheel kind of thing.
Yeah. It's really cool, I think, because, two motors located off to the side, out of the way, and then you have a light gantry that, isn't overloaded. And we're thinking that to get some, vacuum and electrical to the head, to the effector, what you could do is use like a high bend radius Teflon tube or something, and then have another thing completely separate just sitting off to the side, out of which the tube goes up, arcs over and down, and then and then goes into the effector head to deliver whatever is needed, be it material, liquid, vacuum, electrical.
Interesting. So what is the other motor for? Is that just for Z height adjustment?
Yes. It's too bad that thing's on there because it's not needed. So that was a little Z thing. But you can see the problem is here. By the way this thing is configured, they made it super minimal, so that what goes out there isn't that much. But you can look, this is pretty low mass. you know.
Yeah.
But you can use like I think a Teflon tube to get anything you need out to the effector and just let it bend, you know, and you can put that thing, put the base of that control thing way off to the side. I have a couple other pictures here of it. So here
Yeah, I
you
want to
can
see the insides of that. Be good to see how they're manipulating that belt.
You see that little bearing there? I don't know if you can see
Oh,
that
yeah.
cursor.
Yeah.
Yeah, so that belt goes all the way out, comes this way. It's a real funny concept.
Interesting.
It's
kind of
actually
like
doing a 90-degree at that bearing.
Yeah,
So,
it
so
is
it is a single belt that's hitting all 4 points.
Yes.
Interesting.
I guess what do you compromise? Torque, I guess. It's best for, I guess, low torque applications, I would imagine. Like you wouldn't CNC something with it.
Yeah, you don't have a whole, I mean, there's a not super rigidity because there's rigidity on the first thing, but then when you get all the way out to the Y, well, that thing is running on a linear bearing, and you know, it goes in and out.
Yeah, and since you're moving the whole rail, it seems like the center of mass is like shifting quite drastically. Like that whole rail's shifting, right?
Well, yeah, it goes left and right,
Yeah.
and that's riding on a linear bearing, and then you have that Y
That
member.
top one, yeah. That
It's
one
on
is
a perpendicular linear bearing. Let's see, I have one other picture. Was this the first one? Hold on. There's one other. Wait, maybe it's this one. Yeah, here you go. So,
oh, that's a good one there. Yeah, you can see
yeah,
it there.
you can see there where it turns in, and
it's pretty cool.
It's such a neat, I don't know how someone thought of this. I mean, you look at it, it's like pretty simple, but it's kind of like a Delta robot, you know, but in 2 dimensions. Anyway, so Doug thinks that Parallax can sell this thing for $300.
That's pretty good. How are you
Yeah.
getting just the everything machine from China, I guess?
Well, a lot of these motors, okay, they come from China. And like I said, hopefully they have good firmware, but I kind of doubt it because that's not where, you know, that's not typically where things are the best. I mean, they probably got the mechanical side pretty good, but who knows what the software is. You know, you could probably open that thing up and put in new guts and make it really well in case it's not well. Hopefully it runs really well, but I kind of doubt it. But it might be good enough for a lot of things.
I think a lot of the modern CNCs use the trinamic motor drivers now. That does the whole trajectory planning for you. Just end, start.
Oh wow,
Velocity acceleration, yeah.
Yeah, so they're it's like high level of abstraction.
Yeah, so I'm sure I would assume they're using that. I know like Bamboo's using it, and they have like internal current sensors to know when has like a stall guard feature too.
Yes, it was such a great idea to put all the load current or the load
right
load driver right into the motor, and then get all that crazy induction out of those wires. You know,
that's
and
true.
Right there. Anyway, this little effector, see, you can see where these got this thing screwed on.
That little lead screw.
Little cap screws or star screws. Yeah, you can put whatever you need out there. That thing, I think, is designed to hold a Sharpie pen so that it holds it not tight, but so that it can move up and down as needed. So you could put this thing over a piece of paper and then drop a Sharpie in there and draw pictures and things.
I will say it looks like the disadvantage of the system is that you need a much bigger working space because that whole rail the top rail has to move back and forth.
Yeah, the envelope is a little different. You know, you have to have some space behind it, but it sure makes for an elegant design.
Yeah.
I mean, it is very rigid. I held it the other day, brought it over, and it was very rigid. And he can get higher quality linear bearings to go like in this Y member. He's got some Chinese ones in there now, but you know, the idea can be executed well if you use high quality parts.
Yes, you've got the envelope is twice the length of the Y bearing.
Yeah.
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 Or you this reminds me of the old days of engineering XY plotters, you know, that were in common use 30 years ago.
Oh, yeah.
Where you could have a different colored pen, one at a time, and you could draw sine waves or circles or graphs or whatever on a piece of paper. And
Yes.
those were very common a long time ago. Of course, nowadays we do things a lot different, but that's what this reminds me of, because it was driven similarly to this, but I think it used two different belts and you know, for doing its movement of the pen. This is really kind of neat though.
This looks like it's actually using two belts, right? It's using one closed loop on the left and then one closed loop on the right that hits two bearings.
I think it's all one belt
Because I don't see the belt loop around on the top side. It just goes on the right, but I don't see it coming back.
Here it doesn't loop around. Back here,
right?
I remember seeing those straps were terminated, but I believe that here.
Yeah, it looks like it just goes, your cursor goes straight up, right, left, and then up again. Makes like a T shape.
That'd be two belts.
Yeah, so it looks like it's two belts.
If you go back to their previous picture, Chip, it'll show underneath in the center there where the belts seem to wrap around.
Yeah, it's going
And
all
there's one
four
continuous
spots.
belt for a whole thing.
Yeah. That's what I was saying. That's the only way it could push and pull by reversing the one motor.
So you've got two more of those bearings on the other side that we're not seeing.
Well, I think there's some idlers in this effector housing that the belt wraps around.
Mm-hmm.
Otherwise, it wouldn't be able to do anything, I think.
It's a big plus
what
sign.
we're not seeing is the idlers in the Y section.
Yeah, there are idlers in this housing for the effector. There's got to be, just like there are over here.
Is there another pair on the other side of that?
No, at the far end.
No, not that end. Over to the left.
Here?
No.
Here?
Across the rail from the two idlers that we see.
Oh,
there's no space for any over
it looks
there.
like it's
yeah,
just
it looks
one
like
or something.
there's a big offset, so probably not.
So how the heck is it making a turn?
But wait a minute, let's look at it overhead. No, well, yeah, it is offset, isn't it?
So that's why it looks like it's making a T on the right side and then just a circle on the left.
No.
The heck?
Oh yeah, maybe this belt, maybe there's only one belt on this side because it only pulls.
Right.
But it pulls on this or it pulls on this.
Right. So I think, yeah, so that moves the effector left and right, and then the other one just moves it back and forth. The other motor moves the whole thing back and forth.
Yeah.
We confused those.
Oh, no, look, no, you can see the belt down here. See that under there?
Yeah.
Ah.
Oh,
it's
there
on the
it
other
is.
side.
It's just very
It's just
difficult
hidden.
to see it.
And I remember seeing them on both sides here too.
Oh, okay.
See, they're clamped out here. That's like a dead end out on the end.
Makes more sense.
Got two ends out there and we're looped everywhere else.
Yeah, so there must be some idlers in this housing. That's probably what that screw and that screw are for.
That makes sense. Yeah.
Too close.
Yeah. Okay, anyway, that's the robot.
Huh.
So
Pointers.
Okay, let's get to the dreaded pointers here. The controversial triggering pointers. Here we go. So this is, so here's a little thing I just wrote when we were sitting here. You have to do this no, do we even need that really? That only enables like size of, and I don't even think we'd have to do that because see, none of this amounted to any new keywords, right? So it's just part of the compiler now, regardless of what level you select. So anyway, I had this repeat too because we only need to do one for now. So the idea is here that I've declared like a byte pointer variable, right? Instead of a byte, this little guy means this little thing means it's a pointer. So it's a byte pointer called P. So there's something else I got to show you. I'll get there in a minute. So the way you actually affect the pointer itself is you put it into brackets. Once it's out of brackets, it's like an alias for the variable with the hidden pointer in it. So P is the thing that's being pointed to. And then this causes like a post increment to occur. But you're not, I'll show you the big picture in a second here. So if I run this, you can see it hit each character, right? THIS space. And so P was always a byte, but it was, a pointer to a byte. This incremented the pointer, but we could do this. Let's do it like this. Let's put a pre-decrement on that, right? So now what this is going to say, it's going to say decrement the byte and then increment the pointer. So if we run that, we get this. So every letter is one less than it was. Okay, let me go to the, I posted a picture here, which I subsequently deleted. I was thinking maybe it wouldn't be good to delete it, but I did. Okay, this right here, let's see. Okay, I'm gonna move this window. So this is kind of like the, overview I put in the notes for the peanut file. So you have here, this is just a picture, so I can't highlight anything, but you guys can see my cursor, right?
Mm-hmm.
Okay, so this is all about the pointers. From this bullet down, it's about the pointer. So there are pointers for bytes, words, longs, and structures. And you can pass, if you use in a method, if you put like, caret byte in front of a parameter, it will take whatever, any incoming parameter will be assigned to A, but then thereafter the context will be that is a byte pointer. So you can, have regular longs or you can have these pointers. So at the entrance to methods, you can bring values in as pointers. And then here's all the stuff you can do. So when you have a pointer variable, it's exactly like a regular variable. There's no difference in the syntactical usage. You can say pointer var dot byte dot bracket bit field, whatever you want to do. That's all permitted. You can put an index after pointer var. You can put an at in front of pointer var. It'll be just like as if you're dealing with a direct variable. But with these bracketed operations, you can post increment it, post decrement it, pre-increment it, pre-decrement it, or if you want to have a conversation with the actual pointer instead of what it's pointed to, you just put brackets around it, and then you can say, like this thing here, colon equals at, and then the name of something you want to point that thing to, and it will then affect the actual pointer. But anytime it's used all by itself, it is it's like an alias to the pointed to variable, and it supports all the regular syntax. All right, you guys hate this?
I think this is good.
It's reasonable.
I know this is a departure from how things are normally done, right? So I was very surprised after I posted this thing on the forum, there were like 8 messages. I didn't know there was such life out there, but so people are, they're talking about it. Now here's something.
I think they just don't get the explanation. You might have to post some example code.
Yes. What I think people's expectation is something like this. If you have a pointer var and you can say assign it to some variable, right? Point it somewhere. Then when you want to use it as a pointer, you do this. Well, here's the trouble with doing that. We're getting awfully close to getting back to this. It's like syntactically, the pointers aren't enough of a departure to even warrant their existence. So I figured we got to there has to be some kind of economy in syntax to make this whole thing worthwhile. So doing it this way where, just
Well, the
plain old
other
variable name.
thing with that is that you can replace a variable that just exists with a pointer and not have to change everything else, right?
Right, right. And then things like Stephen's colorizer, what do we call that thing, Stephen?
The syntax highlighter for us?
Syntax highlighter, yes. So it could actually know that, oh, that's a pointer variable, and then it could put it into another color or something so that there'd be some indication that that's not, a normal variable. In 7-bit straight ASCII, we don't see that kind of thing. So, it could be like, well, is that a pointer or is that a variable? But, until something happens to it, it's just a variable.
Pointer is just someone else's variable.
So this is all wrong. Let me get rid of this, right? This is just for example.
This is nasty.
Chip?
Yes.
One thing that's a little confusing is in the var statement, if you have a pointer and then a non-pointer, how is that represented syntactically?
Oh, so you mean like in this right here?
Yeah.
So if you wanted just a byte, you would not have the caret there, and you could declare A, B, and C bytes. But
No,
if you want those
second and third,
right here,
B and C. In other words, A is a pointer, but I want B to be a byte and C to be a word or something like that.
Oh, okay. I could type some code in here just to say, so let's say we had a var block, right? We could say that we want a byte called A, and then we want a byte pointer called B, and then we want maybe a word called C, and then a word pointer called D.
You can also put those on the same line with commas in between.
Oh, here's the thing. Once you define the type, the way the var thing works, once you define the type, they're going to be the same type.
You can't intersperse more types in there in var?
No, once you select a size
Type
or
is only on the left edge. Okay.
yeah, then everything that comes after that will be of that type.
Okay. And that was your question, right, Grover?
Yeah, that was my question. Whoops.
Michael, I'm sorry.
Did it get answered okay? Did I answer it?
Not the way I wanted.
Okay, what would you like? Is this what you'd like to be able to basically put something like this here?
With a comma after the Z.
Oh, you know what? Hey, I think that I can add that in, and I don't think it would hurt anything because the occurrence of byte, word, or long, or a caret would never happen, right?
Right.
That wouldn't. It would never. It would never. If that caret or something like that appeared, that wouldn't be a valid variable declaration anyway. So what I could do is just have it redefined. Why don't I do that? That'll be more like the con blocks then. And I don't think it'll hurt anything. It won't create any incompatibility, but it'll make things more flexible.
And so any type after any comma.
Yeah.
Retype it.
Yep.
Good.
Yeah, and of course, if you don't have anything, that's going to be
just a long.
And I made the pointers so that you have to say like, but I first around I had something like this, but I think that starts to get a little, you understand? That's like an implied long pointer. Called
Yeah,
F.
that's not so nice.
Yeah, because it's kind of ambiguous, right? But
I mean, long as a value is sort of the primitive value of the processor, but there's nothing primitive about the long pointer. If anything, the byte pointer is the primitive.
Yeah. Yeah. You can, yes, that's okay. Well, I can I'm going to make a note of that really quick about, let's see here. I don't need this anymore. Okay, so I'm going to say, let's see. Let's go away from all that money we don't have. And I'll put down here a little note, let's see, make var support
Inline
changing types
types.
on a line. Okay.
Now what's your bool underscore?
Bool, okay. Oh, okay. That is a new thing for debug.
What'd you do?
You're looking at, are you looking at the spin2 documentation?
Yes, I am.
Okay, not this, okay, not the one I just put on the screen.
I got some learning to do because I got to highlight this stuff.
Right, okay. All right, why, okay, let's, hold on. Oh, I got crazy windows covering things up. All right. All right, let me go to that document. Here we are. Uh-oh. Can you guys still hear me? Because, oh, my screen seems
Yes,
to be
yes,
freezing.
it's all fine. It's all fine.
Video and audio are fine.
Okay. So you're asking about this.
Mm-hmm.
Okay, so that is a new debug thing where you can have bool and
okay.
or true or false.
I know what the underscore means then in that case. Okay.
Yeah.
Sorry.
Yeah, he's asking about this here. So
Speaking of debug, there should really be a way in the debugger to print out the current flag values.
wait, to print out the what values?
The flag values, like the carry and zero flag.
Oh, yeah.
Good thought, Ada.
Yes, that never occurred to me. Yeah, so you could use a single step debugger, but debug should be able to do that. Okay. I got to make another note here. Make var support. Okay.
Making a note here. Huge success.
Okay, add flags underscore to debug. I'll know what that means. Okay, yeah, so we'll have something called flags and it'll print out C and Z. And that's a great idea. Yeah, it never occurred to me, but that's what we need. Okay, so
you get a lightweight 46 that's going to come up with some minor changes.
Probably, yes. Yes. Yeah, this took me forever because I was working on this actually like a year ago almost. And then Steve and I embarked on that big project. And oh, look, Steve made a note right here.
You did?
Missing space between struct and name. No, that's intentional.
Well, why?
Because okay, well, I got to talk about structs. So the new way you do structs is you have the struct keyword rather than in a com block. If you see a name with a parenthesis, that means structure. I mean, that was really non-intuitive. I thought, oh, we don't need any keyword because that case is never being used, but it was kind of insane because who's going to know that was a structure?
Right.
So now we have the struct keyword. And so struct name is this. So I just kind of followed, byte, word, long.
Oh, so what you're saying is that's not the word struct in there. That's just a structure name.
Yeah.
How about a hyphen in there instead then?
Or maybe make it like lowercase or something.
Make it lowercase and a hyphen. Or, yeah. Yeah,
like
take out the cap.
Or should I just say, I could just go like this?
Yes, exactly.
Oh, wait. Okay.
Yeah, I mean, we have the convention that the keywords are uppercase.
Yeah.
At least documentation wise.
Oh, you mean to make that uppercase?
No, I mean, the keywords are uppercase. Everything else is not.
Yeah, as soon as you
Right.
made it uppercase, I thought you were meaning the keyword. That's why I commented.
Oh, good point, guys. I got
Yeah,
it.
that's the consistency.
There you
Right.
go. I'm liking
Okay.
that. Same thing up above in the var line, where your cursor is right
Oh,
there.
yeah.
Thank you.
Thank you. There, now we can all sleep better.
Yeah.
Seriously.
Chip, also, you and I talked about some debug enhancements. I'll recall that for you, and let's add that to this minor change too.
Okay. What? Wait.
We'll talk about it offline because you and I had the discussion.
Okay. All right, good. All right, so we covered pointers. So you guys kind of understand what pointers are, right?
Yes.
Okay. So there's all this other business here about structures. Okay. So structures got revamped because the first implementation, they could only be passed by reference, and I had keywords for methods that would copy one to another. So now we've changed things around so that if a structure is small enough, if it's 15 longs or less, it can be passed as parameter or return value. And you can also do all kinds of funny stuff with the assignment. The normal assignment operator lets you pile up any number of things on the right hand, and then you can feed them into any number of things, same number of things on the left hand. So if structure here is 3 longs, this will compile just fine and go, okay, I'm going to put these 3 longs and drive them right into structure. So you can pass small structures by value. So if you have a structure that is 1 long or less, that actually can be passed as just a value. I mean, you can still reference the components like structure.member, but it can actually be passed and thrown around as a value, and it will 0 pad the upper bytes that aren't used, if there are any. And but when it writes back to the structure, it will only write the correct number of bytes into the structure. So that's kind of a fun thing. It makes, if you want to like just slapdash a structure together, you don't have to go the long way and do all the member assignments. You can just say, boom, like if this thing had 3 longs in it, and you know that one's X, Y, and the other Z, well, why go through all the structure.x equals? Just slap it together like this, and it'll just take care of it. Then we have some
question, Chip. Can you put pointers into a structure?
Okay, let's see. Can you put pointers into a structure?
Yeah, like this. Can you?
Oh, that's fascinating. I never thought about that. Let's see. Never occurred to me. I think it could be done.
Obviously, you need pointers in a structure if you're making like a linked list or something. You need a pointer in a structure, of course.
Point to the data.
Yes.
If the element isn't containing the data and it's somewhere else.
Well, I mean, yeah, you can obviously write along and then treat it and then use it as a pointer. But to have a structure resolved to a pointer, that should be possible. I think that there's no syntactic reason that wouldn't work. So the answer could be not yet. But yeah, that's a good idea, Grover. I never thought of that.
Yeah.
Yeah, that's like
that'd make it a lot more
concept for
powerful.
linked lists. Yeah.
Let me make another list here. Okay.
Another
list. Add to my list. So make. Okay. Allow pointers in structures.
Right.
Well, that would be fun. That could result in some crazy looking code.
Yeah.
Oh, that's so funny because you would reference, you'd say structure dot substructure index dot member, and then that might actually just be a word somewhere, right? Because it would become.
Yes.
Yeah. That could result in some interesting write once code.
Michael Green has a question in chat.
Okay. Let's see. Chat. Okay, where's the chat thing? Oh, here it is. let's see. What happens when structure elements are misaligned like long lightning compared to an structure? Okay, can they become misaligned? Let's see. What happens when structure elements are misaligned like long byte long and then compared to another structure? Well, they can't, the structures are packed records. I don't think there's any potential for things getting out of order. Oh, do you mean when, like we're doing?
Alexa, garage light on.
Okay.
You mean with like the slapdash thing, kind of like this? So you have to know what you're doing in a case like this, because it's not regarding any subfields and their sizes. It's just throwing data into them. So you'd have to kind of be judicious about when to do something like this. But I think in a lot of cases, you know, you really want, if a complex structure exists, it's going to have like probably byte string fields of bytes and all kinds of stuff in it. But for simple structures that you just want, I mean, you know, you could put like an index on this thing here. You know, that would be fine.
Is your question talking about the two lines above your cursor?
You mean these?
Yes.
Oh, okay. So what this thing does, now this is funny. If these are both long size variables, right? If this structure A and structure B both fit within a long, it's just going to throw them on the stack and do an equality test. So it will zero pad them, right? So they should match. And then if they're bigger, if they're too big to fit on the stack, then what will happen is, or if they're bigger than one, I think I have it so that, yeah, if they're bigger than one long, then what happens is a special byte compare gets called, which compares the two strings of bytes. So it doesn't make sure that the structures are of the same type, because then it kind of ties your hands in some things you might want to do. What it does is it makes sure the left hand and the right hand structures are the same size. So you wouldn't want to compare stuff that was not the same type, but you also want the flexibility to be able to recast things into other forms in some cases. So I didn't make it so it makes sure these structures are the same type, because that would have been kind of limiting. It only makes sure that they're the same size. And in 99.9% of cases, people are going to have the same type there anyway. And if they mix up the types, chances are they're going to get the sizes mismatched, and that will throw an error.
Question, Chip, the structures themselves, if you mix longs, words, and bytes, are they packed essentially?
Absolutely, yeah.
Yep. Does that answer the question?
Yeah, I mean, I've been through this with a Pascal compiler, and the problem is the padding bytes that may or may not be there.
Oh yeah. Yeah, no, that kind of stuff's the enemy to sanity. It's anything that's big and complex should probably be packed. So these structures are packed so that you're not going to have all this crazy formatting junk wrecking everything. Because I've experienced that sort of stuff too. It's very frustrating.
Is it already documented?
Alexa, garage light off.
Okay. So Michael Green,
Is it already documented?
yeah, it's in the documentation.
Great, thank you.
Yeah, I don't have many examples, but if you know kind of how spin works, it'll all make sense. It's all pretty direct stuff. So here, like just to kind of overview again, here's a line where we define like a structure called point that has members x, y, and they default to long, so long x, long y. And then we have a thing called line, which has two of those point structures. So it's like point A and point B. So now here, to declare that in a var statement, you would say line. When it sees this word, that's a keyword that it knows that that is a structure, right? Because it was defined up here. I said here, we're going to use it as an example, just so you don't think it's strange. So it's going to define structures A, B, and C, which is an array of 8 lines. They're all going to be line. And then to do these in a method, you could say, if they're small enough, you could just pack them right in by value, pass them and receive them by value. And the way it works is it just counts up how many longs worth of parameters are there. Does it match what is being fed? How many longs worth of return values is there? Does it match what was being fed? And so, when you have a structure though that has, it's not long aligned, it has like not a multiple of 4 bytes within it, it just 0 pads that when it puts it into the register space. So it 0 pads it just to keep things sane, like you're talking about, Michael, where you're not going to wind up with like garbage data that was trailing that's now, messing up comparisons and whatnot. Stuff will compare fine. So it carefully 0 pads everything. And then when it puts it back in the structure, it doesn't overwrite. It only writes the exact number of bytes that go into the structure. So it doesn't overflow or, do its own weird padding on the output. It just makes the exact size data and puts it out there.
Chip, or opinion and a request, asking for your opinion. Can you put a note in here somewhere, and the opinion is where would you want to put it, that structures are packed?
Oh.
Alexa, garage light on.
Dave, you're making us want to play with your Alexa.
Yeah.
You're teasing us.
Okay, let's see. Structures can be declared. Okay, data structures have been revamped back in Okay. New keyword struct, structure else. Okay, so what right here we can just say, maybe here would be, well, hold on, maybe that's not the place for it. This is tricky to get. Yeah, we want to say they're packed. I think I say they're packed, but new keywords used to begin.
It's either in the var section right there, or in the dat. Probably var because it's the first time you're using it.
Yeah, I can say here, structures are packed.
There you go.
And only contain the number of bytes. Well, maybe that's going to be confusing. And only contain the exact amount. Are packed. Maybe I should say structures are packed with no padding or alignment.
There you go.
I think
that's the power of the egg beta. It only takes an extra cycle to do the unalignment.
Yeah.
Or alignment and no padding, alignment.
Structures are packed with no padding or alignment.
There you go.
Okay, good. So they're dense.
Thank you.
Okay. Should that go there or should it go down below? Well, it kind of needs to be said early on, right?
Yeah, I like it early.
Okay. Yeah, thanks for pointing that out. So let's see, going down here. So if you bring in, if you declare like a parameter or return value is a type of structure, then it has to be within 15 longs, including whatever else you have in the like return values. The parameters can be up to 127. So you can pass in lots of, small structures by value and do it.
Lost your audio.
For a DAT section, if you want to.
Chip, your audio blanked out there for a little bit.
Oh, and can you hear me okay now?
I can.
Okay. If you want to do in a DAT section, if you want to make a structure, what you would do is you put the name of the structure. We'll just call it stru for now. And then you'd say the name of the structure. Let's say we have line. And then you have to put an end of line. And then on the next one, you put in your data. And it's not tracking, what you're doing at all. It's just you have to put on the pants and, make sure you get it straight. Because this whole matter of trying to feed data into structures from lines got to be really, really complicated because of all the potential there exists for complexity. And so I figured just, what we need in DAT is just a way to, declare a variable, the structure type, and then let the user put in whatever data belongs to that. And so let's say he wanted a huge array of these things. Well, he could just go like this, right? And then when he accesses it, he would say like, stru index, and then he could say .a.x. That would be like, point A, coordinate X.
Mm-hmm.
Okay. So then let's see, back over to here. Okay, so then we're down here. So we don't, I got rid of those keywords. Let's see, did I mention that I got rid of, yeah, okay, so here, I got rid of these structure methods from V44. Okay, because that's kind of valuable namespace, and right now we handle it with stuff like this, like here is fill with zeros, fill with all 1 bits, and then this is copy one structure to another. This is swap structures. So take their contents and just whoop, swap them around. And then these are the 2 equality tests. And then here is just, using the assignment operator to just kind of go roughshod and just do whatever. So it just has to match up the number of longs on the left hand with the number of longs on the right hand.
Is there?
So you could have multiple variables on the left hand if you want. It'll just feed them in. Oh, there is one other new thing that I added that I need to add to that little header up there.
Yes.
Let me go down to where I was talking about these data structures. Here we go. So let's see, did I not? Okay, let me do a search. Let's see.
You might want to correct the term random in that assignment in your narrative.
Okay.
You might want to
So
say
arbitrary.
Yes, good choice.
Okay. All right. Let's
We've been
see.
working together for a while. We're coming up with the same terms.
Yeah. Oh, okay. I changed it over here. Okay. This is in the using methods section. So, you know how there is.
Okay. Hi.
Hi. Did you plug beforehand?
No, because I had my hands full and because I figured we're gonna go out at 4:30.
Okay, hold on a second here.
Just wondered. I didn't see it when I looked out the window.
What?
Okay, yes. All right. So down here, we have these underscores. If you want to ignore some of the stuff on the right-hand side, you guys remember those?
Yes.
Okay, so there's a new form where you can actually say underscore, and then in parentheses, you can put in a structure name, a structure variable name, a structure pointer variable name, or just a number, and it'll say ignore that many longs.
Oh, interesting.
Just toss them away. These are kind of weird examples that wouldn't be practical, but it shows you that you can have it like if some, if there was something over here like a function or method that was returning like 2 structures worth of data and you wanted to ignore one of them, you could put this on the left side.
Gotcha.
All right, now that word random, let me go back and we'll fix that.
Use right there
That
in the
was
narrative.
okay.
Right there, down a couple lines. Where you have the 1, 2, 3.
Okay.
There you go.
Yeah, I see what you're saying. Arbitrary.
Otherwise, we're searching your
Arbitrary.
brain for how in the world you created random.
Well, it's like random access memory.
Yeah, I understand.
It's not like they use random numbers to come up with addresses, but you have to be able to tolerate that.
That's true. Good. Good. Thank you.
Yes. Well, thanks for noticing that. Okay, so that I think pretty much sums up the changes here. We have a new operator, the size of thing here. This, you can put a structure, you can put like a construct name or any structure variable name, and it will it'll tell you how many bytes that is. And that,
Can you also do it for objects?
oh, interesting.
Good question, Ada.
Yeah. I don't know if we would always know,
And then
because
secondly, what would you return since you have both var and code spaces?
Well, it's obviously the var space because the code is shared between all the instances of the object.
oh, so you would want the var space. Yeah, I wonder what you could use that for, though.
Well, in FlexBin, we already have the extension where we can use pointers to objects. So that could, I guess it's syntactically works with that.
Yeah. Yeah, you'd have to
Sure the value yet, but it's an interesting thought.
yeah. Oh. Hey, I can think of why you might want to do that, because you might want to like create dynamic instances of objects, and you need to know how much space to allocate for each one in var.
Yeah, something like that.
You.
Can they make a note of this?
Then you have to be able to point the object to that dynamic space.
Yeah, well, you can you use a oh yeah, how can we do that? Do we have, you know what, we don't have object pointers, right? We have method pointers.
Correct.
But we don't have object pointers.
Yeah, we have object pointers in FlexBin where the syntax is mildly confusing.
I can believe
so
it.
The way you do it is you'd define an object in the object section, but you use the equal sign instead of a colon.
Okay.
And then that defines it as a type rather than one object that's instantiated. I have that in some places when I just want to read the constants from the object instead of instantiating it.
Yes. Yeah, that would be interesting. We would need, yeah, well, we'd have to start getting into memory management to make something like that work, you know?
Well, memory management you can just implement yourself if you need it.
Right.
Like just reserve like a big area, and then you can kind of figure out how to partition it up for yourself.
Yes.
Okay. There's a documentation that has all the things that have been added in FlexBin just for harmonization purposes.
Excuse me for interrupting, Ada, just briefly. I got to leave, so I'll see you all. Thank you, Chip, and I'll be talking.
Okay, thanks. Thanks, Stephen.
Mm-hmm. Bye, everyone.
Bye-bye.
Next question. Function parameter, these are strings, function EDS, inline assembly of ASM additional asset pointer, the object parameter. This is not real. Here we go. That's I will post it in chat.
Okay.
Chat, this is real.
Hey, Chip.
Yeah.
Whilst you've got your little list of debug goodies on the go, is there a statement to debug the contents of the PTRA fields? Or
wait, say that again. Is there a
that would be nice to have a simple one-line debug statement to debug the PTRA elements. So if you've got, if you're passing values to a PASM through PTRA, commonly you've got values in an array of PTRA.
Oh yeah, you know what? Maybe what we need to do is have a version. So what you're talking about is a debug command that you use during in assembly language, because it wouldn't work in Spin. But in assembly language, a debug that could basically like give a report, kind of like the single stepper would. So you could show flat.
I'm just thinking rather because often they're textual values. I mean, they can be presented, represented. Like for example, you've got the command hub. Now let me think. How is it? It's hub long or long hub array. I think you've got byte
something like
word
uhex
array.
long array. You might would want to have.
Yeah, it's kind of almost that command, just that it would be able to accept PTRA perhaps, and then it would.
The UX long array can accept PTRA.
Doesn't output the contents though, does it? Unless I'm using the wrong.
It should.
You're using
Let's
the
see.
wrong thing.
I'll do a debug statement here and see. So debug uhex, and then we'll say point array. Oh, let me get rid of the junk here.
I stopped the screen share at some point.
Yeah, no, okay, let's see, screen share. Yeah, see, oh, you got to see it all the way down there. Why did that data go so far down? Oh, let's, hold on here. Why am I getting all these empty lines at the top of my thing? Anyway, down here it says, and so I just did this line right here. So I run that. And why am I getting all this empty space at the top? What's going on here?
Just as an aside, that would be quite fun to your debug where you decrement P before running to encrypt the message. You could actually use getRand on that side of the P as well, I suspect, and you could make a fun text scrambler.
Yes.
Anyway, so your unhexed PTRA, what's that giving? Is that the pointer or is that the content of?
That would be whatever the point array register has in it.
Yeah,
we could say point array, pointer B in A, in B, and then
so in PASM you obviously have the shortcut that it kind of turns into an array. So you've got the PTRA as the base.
Yeah.
No, what he wants is uhex _ long array with a pointer A.
Yeah, and then
I get you want it to go indirectly. Yes, I see what you're saying. Like, what is point array pointing to?
Yeah, I want to get the value that point array is pointing to. So if you've got pointer A, square bracket 0 square bracket, then you're 0 1 2 3. So you can pull up the values that are pointed to by pointer A.
Yes.
Because
that's a good idea.
Because at the moment, I think you have to assign. You have to, read long into.
No, you don't. You put it. It's UX _ long array.
Oh
It
yeah,
works.
no.
I
What
have
you
done
could
it.
do, yeah, you could say like UX byte array, and then you could say pointer A, comma, there's 8 things after, there's 8 things that can be there, right?
Warning, if you're doing this in assembly, you need the pound sign thing. If you don't, it will use
Oh, right.
register 8 as a length. But this is in spin, so it works.
Yeah,
Right.
shaped. Yeah, for a constant. That's fine. So you okay, so that works, does it? Nice
Yeah,
to
so
know.
let's see, we would go like we'd just say org, and then we'd say debug pointer a comma show us 8. Is this right? And
Now you're missing the thing sign.
no,
How does
what?
it ever say nil?
I don't
How's
know.
that
Well,
go
maybe
wrong?
pointer a was 0.
No, you're missing the sign after in front of the 8 because it's a constant in assembly.
Put a hash in front of 8.
Well, no, that'll be
No, that's incorrect. That's incorrect. You need the hash in front of 8. You don't want
oh,
in
the
front of
hash in
pointer
front
8.
of 8. Oh, duh, yeah. Okay, there you go. So now you can see that's what pointer a is pointing to.
Okay. Excellent. I'll have an experiment. Thank you.
If we don't know, we ask Ada.
Hey, yeah.
I can't remember all this stuff.
Whilst Ada's mind's in gear then. So there was a question on the forum today about asmclk or asmclk.
Right.
Is that now defunct?
Not really.
It still works, but you don't really need it because the compiler will put a clock setter in front of your program.
Yeah.
I mean, I've never been a fan of that mechanism.
What, asmclk?
No, of the automatic clock setter. I think if the assembly file should just do it, right? And then asmclk can be used to set it. There's a practical thing here, which is that after the clock setter runs, it has to copy down the memory contents, right?
Right. It happens super quick. It uses the lookup table and it does giant swaths. So it's basically 2 clocks per long. So if your program is
it's still some amount of time that's being spent.
Yeah, but it's super negligible because it's doing big block reads and writes.
Yeah, but it's probably I don't know. It seems like a thing that probably shouldn't happen. It seems very janky.
Yeah, it's
I like the asmclk approach better.
Yeah.
I think in FlexSpin doesn't have a clock setter feature, so it needs it. And in Marco's spin tool, apparently he added like a checkbox to turn it on and off.
You know, I don't remember. What is the rule for introducing the clock setter program?
If pain, then add it in.
Right. Let's see.
Phase of the moon, probably.
Let's see.
There was a comment that I posted on the forum yesterday that you wrote in one of your documents that said PASM only programs which use non-RC fast clock modes now get prepended with a 16-long clock setter program which sets the clock mode, moves the PASM program down into position, and then executes it. This means that the asmclk instruction is no longer needed at the start of a PASM-only program. This harmonizes with the PASM level debugger's operation where the clock is automatically set.
Yeah. No, it does mean that it's right. I'm looking at that now. It's at the end of the documentation.
Yeah.
Well, what's your guys' consensus on this matter? I put it in there just because sometimes you just want to like write a couple lines of code and you just want it to work and you don't want to go through all the clock setting headaches.
I mean, the asmclk is not that big, but I think it's a good option to have. but I think having it mandatory is kind of not that good.
Yeah, so maybe we need a way to turn it off, right?
Yeah, I guess you do a magic comment or something like that, or like an underscore auto clock set equals false or something.
Oh, well, here's what you do. It says that ASM clock is no longer needed at the start of PASM only program, since a small clock setter program will be automatically prepended to PASM only programs which use non-RC fast or non-default clock modes. So if you just if you say nothing about the clock mode, or you call out
Yeah,
RC
then it doesn't
fast,
happen, but then you have to calculate the clock yourself, which is kind of.
well, you just run the, I just use Peanut and just put the clock setter in there and look at what values it gives you, and then just use those for, you know, that hub set
I
value.
mean, you could hard code one, but I mean, I like the idea better. You can just have it and have the atom clock.
I see what you're saying. Okay, so maybe what
Well,
I
Marco's
need.
solution is to have a tick box toggle. Does that
That's
achieve
not
what you?
my favorite, because I think settings like that should ideally be in the text file. So that ideally you should not be able to change around the settings in the GUI and get a different binary output.
Yeah, I agree, actually.
That is just a path that will lead to pain and horrible suffering.
Yeah, it's like the horrible tabs situation that you can set in the GUI, and then code is very much non-portable then.
It's like underscore no clock set. Put an underscore in front of it, then we know it's like the funny namespace.
Like this.
Yeah, like that, or maybe just
Except
underscore.
Shouldn't it be no
maybe
asm
put a
clock,
K
because
there.
then it's the same word. So shouldn't it be no asm clock? So it actually uses the same word.
No, it should be no. It should be no clock set.
Unless you make it like inverted,
No, because
so it's
the
true by
instruction is
default.
ASMCLK.
Oh, wait. It should be like this.
Yeah, that's something like that. Yeah, and if you have that defined, you can it's like.
Or we could say clock set off.
But
No, it's not something you turn on and off. It's something that's there or not there. That's a different modality.
We just need to turn it off. We could say clock set equals 0.
Yeah, I'd maybe set auto clock set or something like that, so it's clear what that that's.
Oh yeah, auto clock set. Or how about auto clock?
Oh yeah, that's nice. And well, the set, I think you need the set. And then if you say equals false, then it turns it off.
Okay, all right. I'm gonna put that in my notes.
So hang on. So what am I missing here? Because the instruction, right, is ASMCLK.
Well, it's not an instruction. It's like a magic macro.
Okay, well, the magic macro, the well-established magic macro that everyone knows and recognizes is ASMCLK. So therefore, why wouldn't the constant to turn off ASMCLK be no ASMCLK?
Well, you're not turning it off.
Because
you're
now
turning it back on.
Auto clock set. What's that? Oh, that's to turn off ASMCLK.
Hey, maybe it's auto asm clock. Auto underscore asm clock. That maybe is correct.
No, asm clock doesn't do anything until you put it into your assembly program. If you don't asm clock,
what you're saying is that we want to make it not.
Let me talk real quick. What if the number is called underscore auto underscore asm clock? Because it only affects assembly programs anyways, right? And that sort of creates the link to the asm clock macro. Are you getting it?
No, say that again, Ada.
Rename the thing underscore auto underscore asm clock.
Yes, like, well, wait a sec. What about this underscore business? I'm not getting something.
Just what let's just post it in chat what I mean.
Okay. Let me look at chat here. Oh, here we go. Okay. Okay, auto ASM clock. Okay. Yeah, so ASM clock, that's actually like an instruction, right? So if you never put that instruction in your code, it doesn't exist. But it can always figure out what to compile for ASM clock based on your clock settings.
Yeah, I think just renaming the variable to this is useful if you in establishing the link between the that if you have this set to 0, you need to put the ASM clock yourself.
I gotcha. Okay, I gotcha. Even though it's not really ASM clock, it's doing the same thing.
Yeah, I mean,
okay.
I guess the clock setter has the same sort of sequence of instructions in it, right?
Right. Yeah, it does. Yep. Well, I mean, yep. It's contextualized a little differently, but yeah. Okay, so auto ASM clock equals 0 or false. Okay, should we okay, we need to kind of call it auto ASM clock as opposed to just ASM clock, right?
No, you have to call it auto because it's referring to the clock setter, right?
Right.
And you missed the beginning underscore. That's very important.
Oh yeah. And that wouldn't be good, right?
I mean, that could also work if it's shorter.
Because it's not really, I mean, it performs what ASM clock does, but there's...
I mean, the ASM is important because the spin interpreter will always set the clock, right?
Right. Oh, yeah. That there is other need for that. Okay, so auto ASM clock equals false. Okay. I will add that in.
I mean, speaking of things that you can prepend to the program, I've found something interesting. I think I've talked about it before. The whole compression idea, like you can compress the program and then uncompress it at runtime. I mean, that definitely slows it down a little bit. But if you're downloading over the serial port, it will actually speed it up.
Oh, yeah. Great idea. Yeah. Well, with, the way it works is your code shouldn't have much, compressible stuff in it, but it might.
Yeah, that's a good question. I think Marco added it and he has the same bytecodes and it works for him. I've implemented it for FlexSpin. FlexSpin, I think we talked about this before. FlexSpin has the funny thing that when you add like a lot of zeros in a dat section, those zeros will actually show up. No, not the dat section. I mean the var section. If you have a var section that's really large, then all those zeros will actually show up in your program. And
yeah, on
so
mine,
that's kind
I fill them. Yeah, I fill them before we run the program, so they don't get downloaded. Only some pointers get downloaded.
Yeah, I think there's some abstraction that causes this to happen, where var and stat sections are actually the same in some level. Get lowered to the same thing in some level. I'm not entirely sure how that actually works. But I think it also can work on the bytecodes, or if you have like text in your program. I'd have to check how much it actually does on Peanuts programs, but I don't really have a large enough program to test it on.
Yeah, please don't make this mandatory, Chip.
I mean, if you make the ASM clock non-mandatory, then the compression should also not be mandatory.
Well, yeah, right? No, this doesn't happen until you put it in.
Well, remember, there are some of us doing real-world practical things. And for example, I spent a lot of time figuring out how to get a binary image from an SD card into the into the flash.
Oh, no, of course. You mean file compression, of course, or download compression?
That's what I mean. Yeah, I don't want to have to put in a decompressor into my product code.
Of course.
Actually, this wouldn't be needed, right? I've posted the standalone compressor. The decompressor program is really tiny and gets added in front of the
I don't care. I don't want
program.
I
No,
don't
no.
want it. Don't pollute my programs with
No, John.
silly
it would-
nonsense.
It
It
would have to
uses
be-
absolutely zero RAM, right? It's similar to that clock setter thing in its operation, or the debugger. It sort of just disappears into the ether after it's done doing
Hey,
its
you
thing.
know what?
Listen,
livelihood-
we're making commercial products, and you're doing these fanciful, airy-fairy things that don't impact you or a manufacturer you're working for. So please stop.
Well, John, this would be not at all affecting any base behavior. It would be something that would go on top if the customer wanted it to, or he could, I mean, it would not affect what you've done at all. Because
Again, that's why I asked, let's just not make any changes to the binary image stuff.
Right.
That's mandatory. And then Ada certainly chimes in and says, no, you're going to do it my way and like it.
No, because it's not mandatory. That's what Ada's saying.
No, you
It's like-
shouldn't. I'm saying that you should never have the. I'm against the clock setter thingy because it adds things to the binary image.
I'm
that are
not
weird.
talking about that. I'm talking about compressing the binary image.
Right.
I
Well,
mean,
look, we
that's-
can't change the ROM.
I mean, if I'm against the one thing being mandatory, then I'm also you shouldn't compress it by default. I mean, there's nothing that unless you're specifically looking inside the binary file, or you're relying on what the uninitialized memory is, which are both sort of niche use cases, then the compression is completely transparent, other than it takes like a couple.
Yeah, it would be, John, you don't have to
oddities
worry about that at all.
All right. The one thing,
I mean-
Chip, I would ask you to add to Peanut, because right now you output a binary file, but it's missing 4 longs that I guess the downloader insert into that, and then it also prepends some kind of communications things that the downloader needs.
Oh, that's right.
I want just a, remember, back in the
Yeah.
good old days of the P1 where we had just a pure binary image of the EEPROM that we could copy in. That's what we do in our laser tag guns. We have 5
Right.
different programs that run and we can't fit them all in one space. So we just load them off the SD.
Right.
We want to do the same thing with the flash. And what I ended up doing after you told me about, okay, this chunk up here is the loader thing. Here's your actual code, and here's how we figure out these 4 values. I did that with a Python program. Now, Marco, to his credit, I said, hey, can we make a file standard? Because you're already doing your binary the way it is. So I said, can we call this P2I for P2 image? That is just the raw code that would be, if I did a copy off of my flash now, that's what it would be, with all of the
Right.
pointers and everything sorted out. Now Marco added that and I tested it and it worked. And if I do a thing from Peanut, I have to run it through my Python program to clear out the cruft, to use your favorite word.
Right.
And set up those 4 values that.
Right.
I mean, ostensibly a problem is that the 4 values are sort of derived from the actual binary. They're not part of the binary. The binary
I
is what gets.
understand that, but if you're creating the actual binary and then you can put those values in.
Yeah, you'd have to have that as a separate option, though. It's not the normal binary then. It's like a binary with.
I'm okay
salt
with that.
extra on
That's
top
why I
of that.
asked for a different name extension so that I wasn't superseding what already exists. But even in the the Propeller tool, it's old, but it has a binary output that doesn't work either because of those values are missing.
They were like checksum values, right?
Yeah. There's 4 longs. Yeah, and you end up, it is, one of them is the total length of the binary. And I think that's probably being, it was pretty, you explained to me what they were. And once you did, I was able to write a Python program to fix them.
Right.
And create a clean binary that I could put onto an SD card, and then the product would update itself. And that's what I want to be able to do without extra steps.
Yes.
Thank you.
Got it. Okay. Yeah.
Yeah, because this product that Josh and I are working on before we get on the road to Florida tomorrow has a P2 in it, and we know we're going to want to update it down the road.
Right.
And we don't want to have the customer open it up. And John Huffman, who I see just came back, he has the same needs.
Yeah, me too.
Yeah, understood. Any compressor would be kind of like the clock setter program. It would be something that would get prepended and
Yeah, that's
totally
how
wouldn't be
it's
necessary.
implemented. Let's see if I can.
It'd be fun to totally just, you know, reduce load time dramatically. That's kind of a cool idea. But I don't know that typical downloads would lend themselves to compression very well.
Well, the
bet
flex
you
spin thing
never
with the
even
many zeros
noticed.
compresses. With flex spin, you definitely notice that it gets faster when you
Yeah, 'cause
compress
it's
it, but
run
that's
length.
because of all the zeros. It's not fully run length. It's an LZ compression that it's being used.
Oh,
You
LZ.
you could do like a more complex thing that takes the probabilities of different bytes into account, but then it would increase the size of the decompressor and make it more complicated.
Yes, yes. No,
And
run
this
length
already
compression is
does it pretty well. It kind of, run length compression is essentially a subset of LZ compression, because
Yep.
in LZ compression, if the match overlaps with itself, then it becomes a run length compression of arbitrary length data. So you can run length compress words like if it's the same 2 bytes
Okay,
alternating.
these all have code in them.
Let's see. I can see what that looks like. So that's the startup decompressor. What's that? Oh, extension crashes. Because you can see it's about this length.
Are we gonna do the
And
same thing on that one for in?
yeah, you can see it doesn't really do anything.
What's that?
That complex.
That's the whole LZ decompressor.
That's LZ4. Yeah, that's the decompressor for LZ4. Yeah.
Oh, that's like nothing.
Yeah, that's nothing. And the code to compress this looks like
We're gonna do that.
this is
Sure,
this the script
we'll have
version.
it.
You can do this in anything
What
where you
is
can
that?
get in
This is
the library.
you handed these set of LEDs to me. This is the in.
Oh yeah, that was my test wire.
Yeah.
We yeah, so we should have, if we have wire, because this should be, because with these where's my
22 gauges aren't gonna be big enough, right?
22 gauge for not to run all the LEDs.
I'm guessing John
Need to
doesn't
bring-
realize.
Unless I may have
it's not
steered you
muted.
wrong, so I'm gonna beg forgiveness right this second. You said something about bringing 5 volts directly to here. How were you doing that? The 5, because this is these 3 wires. That's the power and signal to the
John, don't join the wires up.
Is Michael talking to
Boom.
us?
No, sorry, it's me.
Oh,
Don't connect those wires, John.
God. I
Kaboom.
almost muted you, Michael. I thought you were
Sorry.
having another conversation.
No, I was trying to catch John's attention.
So anyways, this is the compressor. This is just this Ruby script version. I also made a little version in Python if you can read that easier, if that makes more sense for someone's workflow. It looks the same except worse because Python is arguably worse than Ruby. As a scripting language for doing scripting language things where, like, you know, you want it to be quick. Yeah, you really just compress the thing, you append the stub loader, and it does it. It has a little funny trick here, which is that at the end you've got this compressed length res, and this takes advantage of the fact that after this starts the length data. Like, I think what Chip does is he just patches things into random addresses in the program. I don't know, I don't like that approach, so I just put a res on the end, and then that script writes the compressed size onto the end. That's just what it does. Yeah. If you have like a big program that's compiled in bytecodes, you can like drop it over and I can see what the compression ratio would be.
Yeah, I have, well, you know what I could do? Let me load up my, let's see, parser program.
If you have like a
This is-
huge .binary file, well, you have to send it over somewhere.
Okay, now let me see if I can, yeah, well, I can just try to compress it right here with like pkzip or something, right?
Well, you know, you need to compress it with this particular thing. It's not, you'd need to have either the LZ4 command line tool, but even then that has like a different header size. You really
Okay.
need the thing here.
So I have parser.obj is 136K. Parser.bin, that's probably what you want. It doesn't have all the constants. Yeah,
Yeah,
parser.bin is what you'd want. So
yeah, can you like drop that on like Dropbox or something?
yeah, do I have, let's see, how would I get that to you? Can I attach it here?
There is some way of dropping things into the chat on Zoom, but it doesn't actually work.
Yeah.
Yeah, again, you should drop it on like Dropbox or send anywhere or something, and then
I don't know about Dropbox.
or Google Drive or something. Just something.
Okay. All right. Let's see. There's no way to like, we can only do emojis and formatting in this chat window.
No, there is some, if you drop files on it, it will give you an error message that you're not allowed to drop files on it.
So it won't
Like,
work. All right.
Actually, right now it doesn't even want to do that.
All right. Let me go to, okay, hold on. Here we go. Can I private message you on the forum?
Yes, you can also do that. That's a great idea.
Okay, parser.bin. Okay, all right, file. All right. Every time I gotta navigate through directory trees, I just shrink.
Shrink.
It's just like it's just so
turn into inchling.
tedious. It's so tedious. Okay. Parser.bin. Okay, send message. Okay, there. You have it now.
You've got mail. So let's drop it into the correct directory and see what greatness occurs. Oh, we're still sharing this. Then we can maybe make it a little bit bigger so the audience in the back can see it.
John, are you anxious to see if it compresses well?
So
no, I don't care about it. I just want to do real world stuff, not play.
we have to put the file.
I'm kind of curious. I mean,
now how do I LSL H? Oh, that crunched it down to 38.
Whoa, 1/4 the size.
That's a bit. That's a bit much even.
All right,
like,
so the people. I better.
It shouldn't do it. It shouldn't do that much. Oh, that's a bit. That's a bit. Like, I'm not saying it shouldn't compress this much, but it's odd that it compresses this much.
That really squeezed the bejeebers out of it.
I have to look at what this actually looks like in the hex editor, because that's a bit. That's almost. I'm almost a bit suspicious that there's some issue. There shouldn't really be one.
No, that's just
that's this long.
I'll tell you what, it's mostly symbols. There's like tons of symbol declarations in here.
Yeah, that would do it.
So think about stuff like all those debug symbols, you know?
Yeah, those will crunch right down. Let's see what happens when can I switch this onto the text editor? Then we can see what because it's kind of interesting looking at this. If it could, where is my octet? I want to see my octet. Thank you. So here you've got the uncompressed one. It looks like this. Oh, yes. There's a lot of text in there.
What? Wait, what is that? What is that doing in there?
Anyways, there's a lot more. But maybe like a test thing or something. If it's a
Oh, no,
parser, they
those are
might have-
symbols. Those are symbols.
No, that's just straight up text in here.
Oh, wait a minute. Why is that? Why would that? Oh, you know why? Because I included some file at some point. Let's see,
Yeah.
that it was going to work on, but how big was that? Oh,
I
yeah.
mean, if you have,
Okay, well, it's not that big of a, it's a, kind of a
yeah.
small file.
Yeah, so this this stuff compresses like oh, there's a lot of zeros as well. So yeah, that it makes sense that this one would compress well. Yeah, that took a huge chunk out of that one. Compressed one looks like this. You can still see that there's that you can see a lot of the words or sort of like fractions of words. That's because it doesn't actually change the byte values. It just treats the bytes as bytes. That's why the decompressor is so small. It's because this doesn't really do anything. It just like if it sees something that repeats, it like copies it back around.
Right.
And that's why you
know
can
what
see a
would
lot
be,
of the.
what I thought would be important and nice is to be able to compress the stuff that goes into the debug data. Like to compress the debug data by having a way where it's like, because oftentimes a lot of, like think of like in the plot display, there are all these keywords like set, line, you know, that repeat all the time. To be able to reduce those would be handy.
You mean reduce them at runtime or reduce them for the download? Because if you apply the compression after the debugger, then it compresses the debugger as well.
Oh, right. Well, I don't know.
I mean, you could do it in the debuggers. You could compress the debugger strings like this, but you'd need a dictionary because it's a lot of small strings instead of one big
You'd
one.
have to have some kind of dictionary and a way to quickly reference the contents.
You can do this with the LZ4 thing, but the problem is that then your decompressor becomes a little bit more complicated because it effectively what the dictionary is. It's just a file that we pretend is at the beginning of your file. Like
right.
You could get the same thing by just prepending the uncompressed dictionary to the compressed data as a literal. Because when it back references outside of the when the compressed data back references past its own beginning, that's when the dictionary gets used.
Right.
I mean, this is kind of let's have to switch back to this thing. This is not a complicated program, but it might not be obvious what it does. So there's this compressed data consists out of these tokens, and the first byte has two nibbles that tell it how many literals and how many match bytes. So in the you can conceptualize the compressed data as being a literal, a match, a literal, a match, a literal, a match, in alternating. Literal might have a length of 0, but conceptually it's always a literal and then a match.
Mm-hmm.
As you can see, there's the possibility that there's no literal, and the nibbles in the first byte of each token tell you how much match there is and how much literal is. There's a minimum length on the matches, so they can't be 0 length. And if the nibble is 15, then it gets extended by another byte, and if that's 255, it gets extended by another byte. Not like the RF bars kind of thing where it's just variable length integer. It it adds 255 and then it reads another byte and adds that on top of it again. So it's kind of a bit like weird unary encoding.
Yeah.
Then there's like just a 16-bit word that tells you the offset for the match. Well, technically that's in between the length for the literal and the length for the match. And actually the literal comes in between. There's a documentation for this that explains it more concisely how this format works. But it's really just that literal match, literal match, literal match.
I'm looking at this file now, this parser.bin. It's full of like, I mean, I see the, I can see, let's see. Most of this makes sense, but there's a whole bunch of like hex, like $000, comma, $0, F0. It's like, what in the world is that doing in there? It's like literal string data.
Yeah, that's.
I don't know why that would be in there.
Yeah, but that's why it compresses so good.
Yeah, but I'm just thinking that this stuff shouldn't, why would I have textual hex data in the binary file? That doesn't make any sense. And that parser.bin, oh, wait a minute. That was from like years ago. Hold on. Why didn't it make a new one? Oh, because I need to do it at the command line. Hold on a second here.
Oh, grab a new one.
Yeah, this is from like parser.bin. That was from a year ago, or almost 2 years ago. So I need to say peanut parser -c, I think. Yeah, now I've got a new parser.bin and it's only 44K.
Yeah, how can it do on that? That's a bit.
Yeah, so let me
smaller.
Let me just do a little reality check and just even look at it. Hold on, where'd that thing go? Hex, edit parser.bin. Oh, all that data is coming from my file that has the font in it. But why? So this looks like it would compress again, but so I must be listing a file in here, which, oh yeah, so it's, all right. It's got a file there with source code in it that it's using as a process to, it's looking at it and parsing it as an exercise. So that's what's happening is we're compressing that file. So let's see if, let me get rid of that and then compile it again and see what happens to it. Okay, hold on here. Yeah, now it's 19K bytes.
Well, that's not really large.
No, so.
Let's drop it over still, we can see what it does.
Okay, let's see, let me just take a look at it. Yeah, I can see the symbols in here. The symbol text. Okay, so John, this will be more of a real world example. All right, let's see here. Okay, we're gonna make another one. Send you the file here. Parser. .bin. Okay, here it goes. Wait, body is required. Well, now it's only saying it's 18.9. How did that happen?
because they're calculated differently with different rounding.
Oh yeah, it's 19K. Okay. I was still thinking it was 40K. All right. Okay.
Let's see what this one. Body is needed. Hello. Yes, we like hello. Where does it live? I need to find where it lives. I need to paste it into the right folder. There we go. Yeah, do this one. Well, that goes down from 19 to 16.
To 16?
Yeah, can we get that?
Yeah. So that wouldn't be worth bothering with.
Yeah, I mean, with 19, it's small, and to begin with, that's like a ratio of, what is the ratio for that? Tell me, funny program. It
Ooh,
should be.
it's a third of, it's like 16, 17%.
Oh no, it's getting, yeah, we're having a terrible time. There we go. That's 15%, almost 16%.
Yeah.
I mean, the SATA, the decompressor itself is like, I think, 100 something bytes.
Yeah.
So that kind of almost starts going into the result of a small file like that.
Yeah, so I think that's representative of more of a real world program. Not only that, but that thing had a lot of text in the form of symbols, which had a lot of repetition in them. So I think a real pure binary program wouldn't hardly compress at all.
Yeah, I mean, I don't know. Would have to get a real one. I mean, I made it so I can have my flex bin binaries that have all the junk in it. I mean, especially if the funny emulators, they use like manually aligned code to particular boundaries of 64K. So there's like a lot of just empty space in the binary. So on those it works like obnoxiously well. Like,
oh yeah.
Well, it just compressed the code a little bit. So
we can take our Peanut program, which is about 700K bytes. It will compress down to like 230 or 270, but we did that one day and I released it and it set off these like virus alarms all over the place. But we had to jump through the hoops to get back into good graces because they don't like, these virus programs don't like to see programs unraveling themselves. It makes them upset.
Yeah, that's don't do it on the PC. It will cause funny things. Well, I guess if you write your own thing, it might actually do it. Might actually not detect it as much.
Right.
I think they might just detect the signature of common compressing programs.
Yep.
Which is and just say, okay, that's decompressing itself. That's probably suspect. If they're doing that, they could just include the decompressor for that, but they don't. If I tried it with the peanut exe file, what would happen? Just for funny's sake.
That will shrink it.
I mean, this is not as good as zip compression because it doesn't do the entropy coding. But I mean, an entropy coder would actually compress the bytecodes really well. But I'd have to program on it, then it would take quite a bit longer to actually decompress it.
Right.
Because there's no space for like a big table of stuff. So I think it would have to put the Huffman table into the LUT as a tree.
Yep.
And it has to walk the tree bit by bit, and that's not good.
In 1980, I was hanging around these guys that worked at Activision, and they were making cartridge games for the Commodore 64. And this Mark Turmel, he made NBA Jam later, he made this game called Toy Bazaar for the Commodore 64. And it was like, it wouldn't fit on the cartridge. It got too big. So this other guy helped him out, and they did like some kind of what kind of encoding was it? It's where you can like take some values and reduce them down to 2 bits. And then other things become longer, but they actually had to like compress, put the program on the cartridge in compressed format with a decompressor there to unravel it, to get it off the cartridge into the memory to make it fit. And it took like, I want to say like, I remember like 30 seconds. It took a long time for that thing to do its thing. It couldn't have been that long though. But it took a long time. The cartridge, you turn the computer on, the cartridge took a long time to boot because it had to decompress the game off the cartridge.
I mean, that's Commodore users that they used long load times. They can tolerate it. Like, I have this almost comical thing. I have for the Commodore like a little drawing program that came with like a mouse. You put it comes with like a nice
pad?
No, it's that would be a pad. It's called Mouse Cheese.
Oh.
Which is a name for a program that's very funny. And you put it, it comes on tape. And it takes like a comically long amount of time to load this program. I don't know why. It just takes that long. Like, oh man, I just bought a new mouse for my computer. Let's try it out. But first, like, wait 15 minutes for the tape to load.
Yeah.
I don't know how long it takes, but last time I tried it, it took like very long. What the idea of compression there comes in. I think the actual good compression tools that they develop these days, they take like 4 seconds or something to decompress something large into memory. In place even, so you don't need to have the memory for the decompressed and the compressed one at the same time. Like you get that with a lot of the programs these days. They load very quickly, but then they have this little flashing thing in the corner, or like the entire screen goes crazy while it's loading because it's decompressing.
Yeah.
It's kind of interesting because I have for the Commodore, I have like a cartridge that can load things off SD cards. And one of the things, it has a full emulation of the floppy drive in it for compatibility, but it also has the option of just turning on DMA and just writing the executable into memory, and then like setting the processor up so that it boots into the executable.
Okay.
Interestingly, if the executable is compressed, then the slow 6502 has to decompress it, and it actually takes longer. Whereas if you load it in real mode, it will actually be faster because it has to load less. Very interesting, that is.
Yeah. Hey, someone's here to see me. I got to talk to them for a minute. You guys talk amongst yourselves, okay? I'll be back in just a minute.
Yeah, I guess like, you know, I would guess like the tape drive, wonder what the baud rate it could actually store to the tape.
That actually depends on what the software is doing. It's kind of just the software just writes bits into it at some speed and it tries to read them back out. I think the default thing that's like built in has like 300 baud or something. Like it's not very fast. But if you can load a program that understands a faster bit stream, you can do that. And that's how they often did it to reduce the load times. And once you do that, of course, you can also save the length of the tape because the length of the tape is sort of directly proportional to how long it takes to load. Very funny, that is.
I'm back.
Oh, Chip, it's now that you're back. That's just another thing that has at some point spooked around in my mind. Which is there somewhere like a bit exact documentation for the Cordic instructions? Like if I wanted to have a program that runs on like the PC and gets the same results, is there is there the thing for that?
Partially. I've got the log and I got the qlog and qexp coded because I needed them for the compiler, but I don't have all of the other stuff. The other stuff I didn't really need to do because they involve multiple inputs and multiple outputs. So it doesn't work as an operator, but qlog and qexp are just like unary type operations. So I implemented those. So it's in the, you know, the public one that has the compiler in 386 assembly. It's in that. You just look up, just search for qlog or qexp.
Ah, that exists, but I'm actually interested in the vector instructions.
Yeah, those. Yeah, the thing is, yeah. See, I didn't have any occasion to translate that because you can't express in constants. We can't really express. I'd have to make the compiler way more complex to take advantage of something like that.
Yeah, you need to be able to run the function in constant expression.
Right.
Yeah, it have, and then it has multiple outputs, and that is called brain.
Yep.
Brain implosion energy, 10,000 grams of pure caffeine. This you can't overthink when your heart stops. That's not it. Well, is it?
You're gonna get James singing here in a second.
Mind you, this is the real thing. I don't make these things up on the spot. No, you cannot buy brain implosion energy. It is not real product, but the jingle is real.
I used to work with this guy named Alan at this place called Needham's Electronics, and he made EEPROM programmers. Some guy called up one day and wanted to buy a wait state.
Buying a wait state?
Yep. He figured out he needed a wait state.
And the first thing that society programs is that we have to buy things if you want them.
Yeah. Right.
I mean, if you search for things on Google and it's something that you could possibly buy, it will give you things, it will just give you websites where you can buy that thing. No, I want information on the thing. I don't want to buy it. Do I look like I have money?
Right.
No, I spend it all on plushies. Come on, give it to me. Where's the file?
I'll have to get out of here in 5 minutes because it's gonna be 5 and this guy who's here, he's a woodcutter and he needs some help with some stuff.
Yeah, but that means I'd have to figure out the Q rotate stuff myself. You mean?
Yeah.
Or can you like put it on your to-do list or something?
ATAN2 is a Well, what we did on the TypeScript compiler, Stephen and I, rather than even do the qlog and qexp, because we can't get bit perfect results, you know, we just used his math, whatever math library comes with TypeScript, whatever it does. We just used those functions and scaled the inputs and outputs properly to kind of make it work. But we didn't bother to, you know, make a bit exact replica of the function.
Yeah,
So it's close enough.
I would like that, because just for certain purposes, like if you want to replay something that you've some sort of input that your program got, you want to replay it on the PC, and you can't, because there's these functions that do things that are poorly documented.
Yeah.
I mean, you should be able to do bit exact math in TypeScript still, because the results of floating point operations, they're actually defined if you're not, like, they're actually defined, right? They're not random. So it's actually possible to do any 32-bit integer operation with 64-bit floats.
Right. Well, what I did, the reason we couldn't get it working, I had put really minor, like, what would you say, like sub LSB offsets into some functions so that they would look bit perfect. Like at the critical points, like at 90 degrees, you should have a, you know, a 1 somewhere with many, many zeros after it, not 0 with lots of 1s or 1 with lots of zeros and a 1. So I came up with these, like, in a couple cases, these really minor, like an 1/8 of an LSB or a 1/4 of an LSB offset, just to knock it into, so it made bit perfect results at the big obvious points where you'd expect them to be. And so that's the thing that gets hard to replicate. In fact, I think to get really close, we actually did add one of those biases into the math operation, which used like doubles. And I think we got it pretty close, but it's still not bit perfect. But who cares, you know? I mean, anyone using those values, it's about, there's many, 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 many significant bits. You know, if the last bit is off by 1, or the count is off by 1, it's probably not.
The thing is, if you're running the program in real time and using the operation, my idea was, like, if I have something like a funny game using it, and I want to say store a replay. It's just a very basic and obvious thing that you might have seen before somewhere, like, and something that of course relates to my sort of stupid things. If I have that, that replay usually just contains all the inputs. So to replay it properly, it has to have the exact same bits in the exact same variables. Because if it doesn't, because it integrates over time, it will get more and more, it'll drift more and more apart.
Right.
And then suddenly the inputs don't match up with the situation anymore, and everything goes haywire.
Yeah, I see. Cumulative error.
You know, like I've seen the Cordic algorithms like readily available, or so. What I haven't seen is like a Cordic that adjusts the scale to not grow the output by about 1.6 or whatever.
Oh, yeah. What I did in ours, because it's pipelined, I modeled it all on the PC in software. And then I found out at which taps I could subtract, I forget, it was like some minor thing where I would do like a subtraction operation at certain stages. And I found out which stages I could do the subtraction operation at, so that in the end, the magnification was completely, you know, 1.0, not 1.6. But yeah, that's something that has to be dealt with, because the first iteration of the thing had it so that it was outputting, you know, magnified stuff. And the trouble is, well, I had a fixed number of levels anyway, so it wasn't variable. But at one point, my implementation had what am I trying to say? Like variable iterations. You could pick how many iterations you wanted it to do. And in that case, the magnification, it's asymptotic towards this, one value, but it gets closer and closer. But now we have fixed length pipeline with fixed number of stages, and the certain stages subtract out. I think they like subtract half or something. Like you shift by 1 bit and subtract that to reduce it. So we do that at certain stages, and it winds up coming out just like pretty much perfect without the decay, without the amplification, the magnification. Anyway, it's 5 o'clock. I got to get going. Now, if you guys want to stay on here, I could just make Ada the boss here. I'll stop recording here. Let's see, where do I do this? Stop recording. Where is this at? Stop recording. Here we go.